afternoon and welcome to Klingspor's Woodworking Shop 21st Annual Woodworking Extravaganza Virtual. I am Mike Z. Joined with me is Chris, and our special presenter at the 1 o'clock hour today is Mr. Randy Johnson. How are we doing today?
Doing great.
Good. So if you could tell us a little bit about yourself and everything that you're going to be presenting today, and then you let me know when you're ready, man. We'll get started.
All right. Well, thanks, Mike, and thanks, Chris, and thanks to Klingspor for having me today. I've been in the woodworking business trade my whole life. My dad grew up with my dad, who was a woodworker, and taught school for a while as a shop teacher, and then went out into the industry. And as far as CNC, I actually got into it back in the 90s when I helped set up a factory up in Minnesota that produced cabinet parts. And that back then, CNCs were called point-to-point machines because we joked about how they basically dragged the router bit around the table to cut a board because it was very primitive programming back then. And bought about $1 million worth of equipment from Italy and set up a factory with some people here in Minnesota. And then after that, I went on and had my own business for a while, and then ended up in American Woodworker magazine for 11 years. And the last half of that, I was the chief editor. And that would be in the late 2000s, early teens. The little desktop CNC started hitting the market. Next Wave was one of them. And while I was at the magazine, I of course, had connections with a lot of those manufacturers. And I ended up with about 5 different CNCs in the shop back in around 2010, and did several articles on using CNC. And as a traditional woodworker, I was really trying to push it to do a lot of the things I wanted to do. I was actually trained as a Chippendale and Queen Anne furniture builder. So I come from a very traditional background. Now here I find myself using CNC. So I've seen it all, really. And I find the CNC, like many tools, is just a real extension of your own skills and the other tools you have in the shop. But of course, I've always been intrigued with technology also. So I took it on, and like I said, I had 5 different machines, wrote a bunch of articles. And then I left the magazine around 2012 and went back out in industry, worked for Shopbot Tools for 5 years, which is a big CNC company out of North Carolina. And then moved back to Minnesota about 3 or 4 years ago. And Next Wave, I had actually used their early products very early on. So I knew the owner of that company. Went and talked to him, and he asked me if I'd come do some training for them. So that's pretty much what I do. Part of my job is to do training for them and technical advising. And then I have a variety of other CNC activities I do in my own. Also spent some time in between there writing a book on CNCs. I got so many of the same questions time and time again. How do you get started with CNC? And so the purpose of the book was to answer a lot of those questions. And of course, it's been received well. And, the whole CNC market, we all know, is continuing to grow and big future here. So, and today what I want to go over is talking about, getting started. And so go ahead, Mike, if you want to bring up the first slide. So what I'm going to share with you today is some information that I cover with a lot of new shark owners. It's part of a Getting Started webinar that I do regularly for Shark. And if you want to see the whole webinar, I'll have information at the end where you can tune in and see that as well. But this is a slightly condensed version of that. And my email address there, if you want to get have any questions about today's presentation or the other webinars, you see the email address there. You can reach out to me, and I'm glad to respond to that. We get started here. So one of the first, pardon me here, my PowerPoint is being a little bit finicky. Let's try and go back and do that again. All right. So when you get started with CNC, of course, one of the questions you're going to come up with is what size machine. And there's probably 2 primary things you're going to look at outside of price, which is, of course, a driving factor. But table size is a big deal. And you'll find machines on the market from small, such as Next Wave's SD100, which has a cutting area of 12 by 13 and a Z travel, which is the vertical travel of the router, of about 3 inches. And you'll find other machines in the market in a similar size capacity, and then you'll go up from there in any sort of increment. And for Next Wave, they carry a HD 510 down the lower 20, which has roughly a 24 by 48 inch cutting area with 7 inches of Z. The Z, we'll take a look at that in a minute closer, but that's the travel, again, as I mentioned, of the vertical travel of the spindle or the router. And that's one number you do want to pay close attention to, because especially if you start getting into cutting things like 8/4 material, you need room for your router bit and the material to fit underneath. And then, of course, if you had what's called a spoiled board or a board underneath your works, you don't cut into the metal bed. You need additional space for that. So just a little bit of advice there. When you're out shopping, make sure you get something with, I'd say at a minimum 4 inches. If you're looking at a larger tool, for the smaller tools, the 3 or 4 inches works okay, because typically you're just doing some small sign cutting right on the bed. I've actually worked with people who actually just run a very small machine because all they're doing is small parts. They're maybe making little, whether it's coasters or little handles or something like that. And surprisingly, the small machine performs well for them. But as soon as you start getting into cutting plywood parts or larger parts, obviously a larger machine makes sense. So this thing I like to kind of give people who are looking for a machine or new owners just an overview of kind of the basic anatomy of the machine. CNCs are referred to, the kind that most of us are going to be familiar with, are referred to as a 3-axis CNC, because there are 3 directions of movement, as are spelled out here. So when you get into CNC, you're going to see a lot of references to X, Y, Z. So you get very familiar with those movement directions. The Z is common on all machines. That is the spindle or router movement. Whereas the X and Y, it depends on this machine manufacturer. There's not a standard layout for that. So in the machine you see here, the Shark 510, the Y is the forward to back movement, where the X is the left and right. But again, that depends on which, how the manufacturer decides to lay that out. The other choice you have to look at when you're buying is how you want to set up your spindle or router. You'll find everything from very small, even Dremel tools are used on some very tiny tools that are used as the spindle for very light duty cutting and engraving. The smallest machine in the Shark lineup is the SD series, and they use a trim router such as the Bosch Colt or the DeWalt for that type of cutting. And then on the larger machines, you'll typically find you'll either be able to use a typical woodworking router or the spindle that you see at the right. The woodworking router has the advantage that it's inexpensive. Most of us have one already. They're standard, dimensions, and so they're readily available that way. The spindle costs is a bit of a cost upgrade from that, but you do have the advantage that you have more control over the speed, the torque. It's water cooled. It also runs at a noise volume that's incredibly low compared to the regular woodworking router. So much so that when it's running, you actually have to be, if you're not cutting wood, you can hardly hear it run. And so you actually have to be careful, because it's actually a safety concern. You don't want to reach under it when it's running. What drives the spindle, you see a little picture in the lower right there, it's called a VFD, and that is a little control box that allows it to digitally set the speeds, and you can control that through VCarve, and then it automatically sets it. So if you want to run at 12,000 or 18,000, it'll automatically do that. One of the places I like to start with in looking at the bigger picture of how do you use a CNC as far as getting started with it, it's often referred to as workflow. And it's where you start out with an idea and you go through VCarve or some other design software, typically VCarve, and then you go through the control mechanism of the machine, and then obviously to the machine and output the project. Now, what you see in the picture here is a quick overview of that flow. And Next Wave's Shark machines and many other machines on the market, you either have an option of running your machine with a PC or with a pendant. The Shark machines offer both options. And they have each of them have certain advantages. The pendant is incredibly handy because you hold it in your hand. You have all the essential functions there. And I probably use that 80% of the time. The computer control option, because you're controlling it directly with the computer, you have a little bit more brain power per se, and you're able to do a few more things with the computer setup. But of course, the downside of that is you're taking your PC or your computer into the shop where it's dusty. So some people don't like to do that. Just a quick side note, most CNCs can be run with either a PC or a Mac. However, if you run a Mac, you have to get another program, which is often referred to as a virtual desktop. One brand is called Parallels. It allows you to actually run Windows and Windows-based programs on your Mac. I run both, and I've had great success running my Mac with my machine or the PC. So if you're a Mac user, there are definitely options out there. And if you want more information on that, just drop me an email, and I'll send you a link to how to set that up. So I'm going to go through some things with V-Carve. I know the next coming up here, we're going to have a whole session on V-Carve. So I'm going to try and not steal too much thunder from that presentation, because I know that they're going to go into a lot more detail on that coming up in the next hour. But V-Carve is such a core element of getting started that lots of times people want to, well, what do I need to do with the software? So what I'm going to walk you through here is just a very basic project. This doesn't give you all the answers of how to use V-Carve, and we'll get into more of those in the second hour. But for now, I'm going to start out and you just start a project up in V-Carve. And if you have V-Carve, you've probably been through this. If you haven't, just kind of bear with me. I'll mention some of the highlights. One of the ways to think about V-Carve or getting started when you're setting up a project to cut on your machine is you need to think, of course, about your material size. Well, V-Carve has a place to set up material size. And then there are some other settings in there which you'll learn about once you get started. But some of the important ones are you have to think about how you're going to calibrate your machine. And you heard me mention the Z movement. Well, the Z movement has to do with the bit cutting into the wood. And one of the settings in V-Carve is referred to as the Z0 position, because you have to coordinate or calibrate your machine to be coordinated with what you have in your software program. In this case, what you see there on the left, we're setting this up so that the router bit will calibrate itself to the top of the material, which is called the Z0 position. Next up, you also have to calibrate the XY axes. And this is referred to as the XY datum position or the XY0 position. For this project, we're going to select the middle of the material. But as you can see on the left there, you could select any four corners or other locations as well. But the middle is a very simple place to start out. Simply click OK, and your initial setups are done. Again, a quick overview of what V-Carve looks like for those of you who are brand new to CNC or considering it. V-Carve has basically three areas that you have to be concerned about. You got the left area, which is your design area. You have the right area, which is your toolpath area. And you have the middle area, which is your project drawing or setup area. There's some other aspects to that, but those are the broad areas you're going to be working in when you're starting out. Once you save your file, if you look at the top of your program, you'll see it also gives a name of what you're saving it at. In this case, I've saved this project as called Idea Light Bulb. And I'm going to for this project, I'm going to start out with a bitmap image or a clip art. It's simply a photograph or a drawing that you have on your computer. You can get it off the internet, lots of ways to get it. And the CNC or V-Carve can't cut directly from that bitmap image. You need to convert to what are called vector lines, which is the kind of line that allows the tool bit and the tool path to follow to do the cutting. And then from there, you're able to save out your actual tool path and do the actual cutting on the machine. A couple of tips and things to consider when you're picking your clip art. You'll notice here in the drawing, you want an item that is a high contrast or solid color type of bitmap. Those items trace much better. As you can see at the bottom half of the picture, we've got some nice clean lines tracing from these images. A trace bitmap is a quick, easy way to create some artwork to carve, and whether you're adding it to a sign or to some other type of project. So it's a quick way to start out, and that's why I like to go over it. However, you do want to avoid certain types of photographs for the bitmap tracing, and typically they're ones with either color or black and white shading in them. As you can see here, the traced images don't translate into very usable lines. It'd be very difficult to carve these. They're pretty messy. It's really hard to see what you're looking at. However, once you get good at V-carve, you could use these photographs and go back in with the drawing tools and actually manually trace them, such as the fingers and the light bulb on the left there. You could go back in, and I do this lots of times with my custom work. I'll go back in and trace the fingers, trace the light bulb, and create my own vector lines for that image. So it still provides a good starting point, just not for the automatic tracing feature. The other thing, too, that sometimes people get confused on is they will import what essentially is a line drawing, such as the top left up there, that cat, and that will create a double line, which can be useful, but as you can see on the right side, really what you get out of that is a line carving. Whereas the cat on the bottom here, the solid image, that creates a single line, and when you V-carve inside that, sometimes it'll cut so deep that it'll actually cut through the material. And so you have to back off and do something called add a flat depth, that you see in the far right there of that cat, which is a flat depth. But the main thing I want to point out here is that when you're importing your bitmap file, realize that different kinds of bitmaps are going to trace in different ways and create different results, particularly if you are using them for V-carving. So again, for this one, we're going to use that little import. I'm going to go back to the routine of importing image here. We're going to import the light bulb from our computer using the import function in V-carve. When you bring it in, you can stretch out that image to whatever size you want and to fit your drawing area. And then, as I mentioned, there's a tool called Trace Bitmap. When you bring that up, it will automatically recognize the image. And you can see that this image here is made up of two colors primarily, the blue and the yellow color. It is the blue color that I'm most interested in. So by checking that box, it then highlights the blue color in what's called the trace color. So that's red now. And it's the red color that's going to be traced as we go forward. So at the bottom, you could click preview, and you can see where it's actually inserted the vector lines around that. And then you can simply apply and close that and go back to your main screen. Now, in the main screen, we've got our vector lines and our image, but we don't need that image any longer. So all we have to do is go into what's called layers, which you can think of layers as like transparent pieces of paper. And we're going to hide that drawing. So all that's left, as you can see on the screen here, are the black and white lines, which is all we need for doing our tool paths. And once we have that, if you want to add some texture drawing, there's a text tool where you could go in and add some text. You could select your font, your alignment, the size of it. You've got lots of options. It's kind of like a mini word processor for adding the text into your cutting area. Once that's done, we have a simple set of vector lines. Move over to the V-carve or over to the toolpath side of it, as I mentioned earlier. And for this setup, if we take a look, first of all, the toolpaths, you can think of the toolpath operations as a lot of different tools in your shop. You know, you've got a sander, a drill press, a bandsaw, a joiner, a planer, a molder. In many ways, each of these toolpaths function like a separate tool in your shop. So each one has a certain application. Some of them we're going to look at before we set up our light bulb one. These are probably the 5 that I find that when you're starting out, they're very common to use. You've got the 2 at the top there called the profile and the pocket one, and the one in the middle is called V-carving, and the 2 below that are for 3D carving. The profile of the pocket, you can think again, like I mentioned, you can think of one as like a bandsaw and the other sort of like a mortising tool for or a handheld router for pocketing things out. And these are just, again, a couple of the applications of how you could use those tools. Once you get going in VCarve and working with your CNC and setting up your projects, you're going to find that there's multiple ways of doing things, whether it's clamping or how to set your depth or how to design something or which tool path to use. So what I'm showing you today is a very streamlined version of that, but you will probably find other ways that you may find more efficient for your particular project, or you may just prefer another method. So again, what I'm showing you right now will be just the very basics of that. The next tool path in that lineup, the V-carve, there's basically two ways to look at V-carving, which uses a V-bit to do the carving. As I referred earlier, you could either go full depth, which you see at the top, or you could use a straight bit and actually limit the depth at which it cuts, which creates two different results. Sometimes you need to do this to prevent it from cutting through the material, and sometimes you do it just for aesthetics because you want that flat bottom for the design purpose. The 3D tool paths have two basic functions. One is a roughing that you see at the top, and typically use a straight bit for that. And then the 3D finishing tool path, use a ball nose for that to give you your smooth final surface. And those are used for when you are importing a 3D model, which is a very different kind of process from the V-carving that we're doing with the light bulb. So back to the light bulb, we're going to use the V-carve for this. And so what we do is we open it up, and on the right side pops up an editing window for this particular tool path. Now, this is where the information gets a little deep, and it takes a little bit of time to learn how to use V-carve because there are lots of settings here. So I'm going to try and hit the high points, but give you enough information to give you a good overview of what you're up to if you're looking at getting started in CNC. So once we open up the V-carve specific tool path, we then hit the select button, which opens up what's referred to as the tool database. You can think of this as your library of tools, and you can customize this to include just the tools you actually have in your shop. And there's lots of settings here to think about. We'll go over those briefly here. But the first thing, of course, is just which bit you have. One of the big settings you have to think about is how deep is it going to cut every time it does some cutting. It's called pass depth. Pass depth you can think of taking it off in layers of material, and that determines how aggressive your cutting is. With V-carve, you have a couple of special settings relative to what's called final pass step over and clearance pass step over. These you can think of a little like a roughing pass, as you see in the lower right, and then a finishing pass, as you see in the upper right. And that's really the function of them. The first one, the clearance path, actually does exactly that. It roughs it out with a very large step over, and then the final one goes back and cleans everything up. And what I have found is the 2 and 20% setting there work really well for most setups. Next up, you've got to set up some feed rates, and the feed rates I've specified here are ones that work well for most Shark CNCs. And again, it depends on what kind of machine you have as far as how aggressive you're going to be with these settings. So I always encourage people, do some testing. But if you are a Shark owner or have other small desktop CNC machines, this 50 to 180 inch per minute range. The smaller your machine, of course, typically the slower you're going to go. The larger your machine, the faster you're going to be able to go. Personally, I've got 3 machines in my shop and 1 in another shop. So I've got 4 different brands of machines that I often work with. But on the Shark 510 that I currently have, I actually find that I'm operating up in the mid hundreds, even the upper 180 degree inch per minute sometimes, because that HD5 is stout enough to take that kind of rapid movement. again, those details we go over further in other webinars at Next Wave. So if you have information about questions about that, again, drop me an email and it can help you out. The basic setup, you need to select your vector lines. Again, so much of doing CNC is learning how to use the software. So the vector line, you select those, and then you're going to what's called calculate, which then actually sets up your tool path, and then VCarve jumps over to this window, which shows you a preview. The blue line's representing where it's going to cut in the wood, and the red line's representing where it's going to cut in the air above the material. There are some settings involved with that, again, that help it be efficient, and as you get into VCarve, you'll learn more about that. You can also preview it in VCarve. It shows you a preview of what the cutting looks like. Vectric has worked really hard to make this preview function accurate. And I would say 99.9% of the time, what you see here is exactly what you're going to get on your wood. So if anything in this preview doesn't look right down to the fact that if your bottom of your cut looks rough, it's probably going to be rough on your final project. So it's really important that to make use of this preview, it's a chance to avoid mistakes. If something doesn't look right, either go back to your drawing or go back to your tool path or go back to both of them and figure out what doesn't look right. I can't hardly keep track of the number of times I've been contacted with somebody who shows me their project that they were starting out with, and the cutting went all crazy. And I go back and preview it, and it looks crazy in their preview, and they had failed to pay attention to this window. So this is a critical window before you go to your machine to double check that your settings are all correct. There's a little process within VCarve where you're going to what's called save out or post-process your file. And within the VCarve setup, depending on which machine you have, you'll select the correct post-processor. In this case, it's a Next Wave CNC post-processor. The good news is once you select this the first time, it will default to that after that, unless you need to change some other settings, but it will default to that, so it'll be ready for you the next time you do a file. And so then you click save. You'll then save that to your computer, and it saves out for the Next Wave products. It saves out as what's called a TAP file or a TAP file. This is a G-code file. All CNCs use G-code file. It's a code file that tells them where to move, but each machine has a proprietary bit of software that prepares the G-code file to run in that particular machine. And that's why you have to select the correct post-processor so that you can run it on whatever machine you have. And in this case, it's a TAP file. Again, one thing, best practice here is before you close out of your VCarve window, make sure and save this file. This is what's often referred to as your design file or your VCarve file or CRV file. It goes by a variety of names. But this is your master file. Save it. Save it someplace safe on your computer. The other file we just saved out, your TAP file, is a different kind of file. That's the machining file that you're going to take to your machine. In fact, if you were to go in and look at the two, and I point this out because you can tell the difference between the two based on their names. And again, the design file is the file you want to protect because if you lose that, you'll have to start over. The TAP file can always be regenerated from the design file. So in a way, it's sort of a throwaway file. In fact, if I go back to cut something I cut 3 months ago, I'll always regenerate the TAP files to make sure that they're up to date and doing what I want them to do. So the TAP file is typically what you will put on your thumb drive. I will not typically put my CRV file in the thumb drive because thumb drives break, they get lost, and I don't want to lose my master file. So back to the workflow chart, this shows you once again how the TAP file or the G-code file fits into the big picture. And as I mentioned earlier, you could either bring that G-code file into what's called ready to control, which is the computer panel that hooks up to the CNC or the pendant. With the Shark products, they both can be hooked up to the machine at the same time. So if you have a Shark product or are considering one, you can have both the computer and the pendant hooked up to the machine at the same time. You will have to toggle between which one is controlling it, and if you use one, it will lock the other one out. So there's a safety feature there as well. But again, whether you bring your computer into your shop or not is your preference, and depending what you're trying to do. Both of them hook up, or rather the computer hooks up with the USB cable directly to the machine, and the pendant hooks up with a special pendant cable. And again, if you're using that, then you bring your USB drive with your tap file to the pendant, but they both deliver the same kind of information to the machine. Part of the prep at your machine is you need to set up the XY data or the XY0 position on your project. So here, if we look back at our VCAR file, we see that we set it up at the middle. So a simple way to do that is draw an X in the middle of your material to designate that that's the middle of the board for zeroing out the machine. On any machine, or at least most machines that I've used, you have a certain amount of dead space in the back of the machine, which is shown here with the white arrow. That's because the gantry needs a certain area to park itself in the back, and that area where the white arrow is not reachable with the router. Again, that's typical on almost all machines. There's certain areas that the spindle is not going to be able to fit. So lots of times when I set up a machine for myself or for someone else, what I'll often do is either use a pencil, or in this case, I actually use some blue masking tape, and I just masked out the area which shows the area, the actual cutting area. So that means I need to keep the board or my cutting within that area. Now I can use the back half of the table as overrun or for clamping purposes, but I just won't be able to do any cutting on the back half. So I need to stay in the front half. On this particular tool, which is a SD100 from Shark, there's no tape on the front because this tool actually overhangs the front of the tool by about an inch, which for those of you who want to do some end machining, it actually allows for that. So some people have set up some jigging to do different kinds of end machining off the tool. That's possible on this machine because the drive motor for that axis, the Y-axis, is actually mounted to the back of the machine. This is not common on a lot of tools, so you'll see a lot of CNCs aren't able to reach it. So I don't do a lot of, personally, I've done a little bit of front end machining, but most of the time it's still flat machining on top. Clamping, in this case, I'm going to rotate my board around and I'm going to line it up with the slots of the table. Somehow you want to come up with some way to simply get your board oriented so it's square to the movement of the machine. And in this case, lining it up either with the tape or lining it up with the slots of the table work fine. I'm also using some simple hold down clamps. A couple of my other machines, I use a couple other techniques. I'll either use screws if I have a spoil board, which I like to use screws a lot, or I have some low profile clamps. The clamps with the knobs are convenient, especially for this setup here, but sometimes depending on how you're orienting your material, the knobs can sometimes get in the way. So I'm very pragmatic when I tell people about hold down. Just use what works. There's just a couple things that you want to avoid. Obviously, you don't want your router bit to run in to the clamp or into your fastener, whether it's a screw bit or anything like that. You want to avoid running into your hold down. The second thing is you want to make sure your material is held down sufficiently tight. I'll occasionally get pictures or questions from users who are finding that their cutting isn't very clean, and it's because their hold down isn't sufficiently secure and the wood is vibrating or just moving a little bit while they're cutting. So whatever hold down method you're going to use, make sure that it's snug down well and you're not going to run into them. So the next part we're going to set up for this project is we're going to take and move the Z all the way to the top of the axis to give us room to put the router bit in. And depending on what your machine is like, in this case, the Shark pendant allows you just to push the up key on the pendant and very conveniently move it all the way to the top and then put the router bit and insert it. Now, it's always recommended, don't put your router bit, shove it all the way up into the collet. Leave a little bit of space, at least a 1/16 of an inch space, so that you're not, in this case, you don't want that curved shoulder of that V-bit up inside the collet because it would prevent proper clamping. You also, on a straight bit, you don't want the flutes or the cutting edge up into the collet either. Now, the opposite is also true. Don't have a whole lot of bit hanging out of this. Some bits actually have marked on them the recommended insertion, but it's usually about an inch. I've seen some customers trying to get more reach out of their router bit. They stick their router bit up and they're only about a 1/2 inch. And that's going to cause a problem. It's going to cause wear and tear on the bearings. It's possibly going to cause some more chatter. You may more easily even break the bit. It's just not a safe and practical setup. So if you need more depth, preferably find a longer bit. But don't extend it too far because that will also cause as many problems as sticking it up too far inside the collet. The next step, and again, I'm going to show you a very basic, simple setup for what's called calibrating or zeroing out the X, Y, Z for the machine, because we want the machine to be coordinated or calibrated the same way that the VCarve file was set up. So in this case, we're going to use the positioning buttons to move the bit over our XY datum point. We're then going to use the up and down buttons with a little piece of paper, and we're just going to jog or nudge that router bit down till it just drags on the piece of paper a little bit. This is a manual way of doing it, but it's quite accurate, and you can it requires no other accessories for doing that. Now that I'm down over my paper and also over the XY datum location, for this pendant setup for Shark, I simply push the 0XY Z button, and it will automatically, as you can see at the top of the pendant there, it'll automatically zero out all 3 axes. So they are now calibrated for this piece of material and the file that we're going to cut. Next up, you want to move that router bit back off the table a little bit just to give it a little bit of clearance before you start it up. Now, one of the accessories that most CNC people either have or add to the machine is called a Z-zeroing touch plate. It is a little electronic device that you put a little wire or magnet onto the collet, and then it connects with the plate and creates a little electronic signal to tell you when it's touched the plate. The controller or the CNC knows how thick that plate is, so it allows for that thickness, and it will automatically calibrate it to the surface of the material. Now, depending on how precise you're working, there are some times you actually may find the paper to be a better option. So I use both, and it just depends on sometimes the projects I'm working on. One of the advantages, or one of the things to consider also, is that once you have your X, Y, Z all zeroed out, and you run a program, and you need to change a bit, when you change that bit, you have to re-zero the Z. You don't necessarily have to re-zero the XY, because if you haven't turned your machine off, it'll remember where that position is. But you do have to re-zero the Z every time you put a new bit in. And as you can see in the top upper left picture there, I'm actually zeroing off the corner of this project because the initial carving in the middle of the project carved away the location of where the XYZ datum was. But since my XY is already saved, I just need to do the Z up there in the left. So with independent and most control software, there is a routine for doing the zero plate. It walks you through several steps of zeroing out to automate that process. So on the Shark pendant, it has the same called a plate application there for zeroing it out. So we're now ready to actually bring up our file. So we've inserted the thumb drive into that. You're then going to click on the USB button or the other button that will allow you to view the file. And in this case, we're going to look for our light bulb file. You can see at the top of the list. Select that. That then opens up a preview screen. And the top screen here has what's called header information. In this screen, it gives you a summary of your V-carve settings. And it's a good chance to verify that what you're doing at your machine is the same as what you have at your V-carve. So if your computer's back in your office or your house someplace and you're out in the shop and you don't exactly remember your settings, you could look here to verify them. For instance, you see where it says material size. It gives you the size of the board that you set it up. It gives you your Z origin, which in this case is material surface. It gives you your XY origin, which in this case is the center. And if you were to push the down button, you can go down and look at some additional information, which will actually show you which router bit you've selected. It'll tell you what the name of the tool paths you used and some other information. Further down is the G code for the file, and you can preview it, but you can't edit it here. So it's pretty much just for preview purposes. But this top part, whatever machine you're using, whether you're using a computer control window or you're using a pendant to run your machine, taking a quick look at this preview information is another step to avoid some mistakes, to make sure you've selected the right bit, the right material, the right zeroing locations. Once you've verified that, you click on the next button, and that'll then take you to the start screen. And there you see the name again of the file. Again, another chance for you to verify that you've selected the right file. The run screen on the Shark pendant has some features that are actually common on lots of controllers. You've got a stop button, which is a cancel button, which is sort of like an emergency switch. And if you push the stop button, everything stops in your machine, which may be what you need to do, but it also cancels all the operations and you have to start over from the beginning again. It doesn't allow you to pick up halfway through because this is an emergency type of stopping situation. If you want to just pause it for a moment to get like a scrap of wood or readjust a clamp or something, you can click the pause button and that will pause the cutting action, and then you can click resume. At the bottom, you also have a speed override. So if while you're cutting, you suddenly realize you're being too aggressive, you can back that off to 80% or 50% to run the rest of the file. If you find yourself having to override the speed a lot, I recommend you go back to your V-carve file and reset the speeds because it's better to do it there than to overwrite it here. But again, this is a kind of a last-ditch effort to prevent your cutting from being too aggressive. In the over left there, on the left side, you'll see some information on transmitted time as well as total time. And when it's all done, it'll give you a total number of an actual run time of how long it took to cut the file. So I mentioned at the beginning, you could either use a spindle or a router, depending on the tool setup. But if you're using a router or like the Colt router, even a full-size woodworking router, I often recommend setting it at somewhere around 70 to 90% of the speed rather than the full speed. It has all the advantages you see listed here, but particularly for a woodworking router, those routers often run in the 25, 30,000 RPM range, which is often too fast for most router bits on small desktop type of CNCs. When I say too fast, if you've ever routed a board by hand and if you move kind of slow, you know how you can burn the wood. And basically, you're creating a lot of little chips. Well, a similar thing happens with the CNC. You end up creating a lot of sawdust rather than nice chips coming off of it. And that heat also, not only do you risk burning your project, but you also can prematurely wear out your router bit. So turning down the speed a little bit, there's a lot that goes into choosing feeds and speeds, and I do a whole webinar and workshop just on choosing feeds and speeds for your tip of material, as well as the machine, and whether it's a large machine or small machine. But the simple fact is you want to typically slow down your woodworking router, and even on the spindle, I rarely run it at full speed. One of the advantages of the HD models, and this is true of many CNCs out there, is that it has an auto start for the router, not only the router, but it also auto starts the spindle, which is actually a feature that you find in much bigger tools. It'll actually auto start the spindle and turn it off, and also auto control the speed settings, which is really nice because you just stick your thumb drive in, run your file, and those features are all automatic. Next Wave also, because it's a water-cooled spindle, Next Wave also has an auxiliary input into the control box that allows you to plug your water pump in there, so it actually turns the water pump on and off at the same time it turns the spindle on and off. So it's all fully automated. No need to leave your water pump turned on all the time or forget about turning it on. So when you're ready to go, you hit the start button and you let it do its work. Again, this is a very quick file. The V-carved toolpath leaves a nice decorative V cutting. You can see surrounding this those little tiny chips. We'll call those sawdust, but it's not actually dust. Those are little shavings, and that's actually what you want to see coming off of your project. Just a couple of quick tips before we wrap up here. One is go with as short a bit as possible. One reason is it'll reduce chatter, it's less expensive, and you're wasting flute edge if you're not cutting with it. So there are straight bits particularly come in different lengths, and I've got 3 different lengths I use, from very short, maybe half-inch lengths, all the way up to some that are 1.5 inches or 2 inches in cutting length. It all depends on what I'm cutting, but generally go with a shorter bit if possible. Next up, when you're setting up your machine, to give yourself the most reach, depending on which machine you have, lower the router or spindle down so it's about 3/4 of an inch off the bed or your cutting surface. That way, whatever bit you put in there will have the ability to reach all the way down. Every so often, somebody will contact me and they'll say, hey, my bit's not cutting to the bottom, and they've got their router set up too high inside their router mount. Or the opposite is they've got it set too low, so either they cut into their bed or their Z mount goes way up to the top and tops out at the top and throws off their settings also. So if you set it up like I have here, somewhere between 1/2 and 1 inch, somewhere in that neighborhood, the main thing is you want your bit to be able to reach that. And then in a real world application, this was a bowl that I was cutting out of walnut, and I was using a 1/2 inch straight bit. That's a 1/4 inch 2-horse spindle, and you can see the nice shavings that are coming off of it. I don't always get shavings that nice, but I know that in this case, I was tuned in well, and I know I had my settings really well, and it was efficient. Got the job done quicker. I saved some time, and it also kept the bit from overheating. So with that, I'm glad to open it up to questions. If anybody has any questions.
Don't see any live, but always remember that these have a little bit of a delay on it, so the questions could be rolling in a few minutes.
That's fine. I'm going to stay online, so if any questions come in, either shoot it to me,
You should be able to see them as well in the comments section over on the right-hand side of the screen.
Okay, I'll watch for those as well.
Yeah, and we also get quite a few questions after the fact. So since this will be posted as a stationary video after the fact, once the live is over, we frequently will get comments on there then. So we might get a comment on that 2 weeks from now. So,
well, that's great, and that kind of leads me, and I'll just bring up the next slide here. Let's see. There we go. So just everybody out there, I mentioned how what I just went through there was some of the intro information. It was part of a webinar that I covered getting started, and there's more information in it. That was kind of the short version of it. But also, for those of you who are shark owners or considering shark, I also do 2 other primary webinars, one that covers just the pendant control and one that covers just the what's called ready to control, which is a computer version of controlling the CNC. And I do some other project webinars and some other tool webinars relative to laser work and fourth axis. And those will be going up in the Next Wave site. And you can sign up for those at the webinar address you see there. And if you have any questions about those or about this webinar after this is posted, you can also reach me by that email listed there at the bottom. Otherwise, I want to say thanks to everybody. Glad you're able to attend and enjoy the rest of the series today.
All right, let's see here. Thank you very much, by the way, Randy, for joining us.
Oh, you're welcome. My pleasure.
Joined late. So Eric joined late, didn't catch everything, but Eric, you are able to rewind it, and it will be available for replay. So I will put your information. I'll put your information in the in the comment section afterwards. That way, if they want to reach out to you. Now, on your webinars that you do, how many do you do a month typically for Next Wave?
Typically about 3. I do a basic series of which is, like I said, this getting started one. I do one on the pendant, which is specific to the shark, and I do one ready to control is specific to the shark. Also coming up in the new year, I'll be doing a series on rotary fourth axis, some on laser, and I also do a whole series on getting started in V-carve as well.
Awesome.
Nice. Well, you're welcome to hang out with us or take a break, and you can log back in, when the 3 o'clock hour, because Randy is going to return and join us for the CNC panel about the 3 o'clock hour. So looking forward to that as well. But we appreciate it.
Should I sign out and re-sign in for the next session, or you want me just to hang out here?
That's up to you. It's the same link that we gave you. So you can drop out, go do something and come back if you like to. And then if we have any questions, we can also, since he's going to be back at the 3 o'clock hour, if you have any questions, go ahead and leave them down in there, and then he can address them too afterwards.
Yeah. Yeah. So the panel, I'm kind of curious to see how this is going to play out, but in my mind, it's good. So we'll see how it goes. But the idea,
I love Q&A sessions.
Market experts, all together. It just seems like in theory it would be a good place to have that. And so we're looking forward to see what 3 o'clock brings.
I do have a question for you, Randy, and it's because you've been in the industry for so long. You've come in different forms. I mean, everything that you've done in your career up until now. Do you think CNC is real woodworking?
Simple answer, yes. Boy, that I'll just tell you a quick side story to that. Sure. So when I started writing articles for American Woodworker, I had other editors basically giving me that side, when they came across, because I had gone to the dark side. But because part of my career, I'm also heavily involved in the arts world and sculpture with artists. And so the creative side of it, and I always saw that there's this creative side, there's the machine side. And I think in the woodworking world, for me, it came down to this. Because I was trained as a traditional woodworker with hand tools, Chippendale and Queen Anne furniture type stuff. My first big project was a Boston Bombay, if anybody knows what that is. A Chippendale Boston Bombay, all hand carved.
Wow.
Developing hand skill using woodworking tools is a little like playing a musical instrument. It requires an incredible amount of dedication, and I have high admiration for those who have that skill, and they have to maintain it like a musician. And like I said myself, I've done a lot of hand carving myself. But as an extension of what I do, whether it's a planer or a table saw or a bandsaw or the CNC, to me right now, those are kind of all the same. Now, a CNC is an incredibly capable tool, but it also has some limits. I can't use a CNC to resaw a board, and I can't use a CNC to get a really super fine surface on something. So I try to keep it practical what I'm using it for. I try to use it what it's really good at, which is reproduction and duplication and efficiency and all that. But lots of my CNC projects, I go back with hand tools, hand carving tools, and finish the project. It's really just one phase along the way.
So it's another tool to be used.
It is. It's an incredible tool, but it is really just another tool in the shop ultimately.
Let's see. We had a question. Raymond asked, is the size the cutting area or the max board size?
I think if I understand his question, it's really one and the same. The table size is typically several inches larger than that. So max board means that. So the tool that I showed, that little SD100, has a cutting area of 12 by 13. But underneath the gantry, you can put something that's probably 14 inches wide, and of course, any length, because it sticks out the front and the back. But the dimensions I showed at the beginning are primarily the cutting area.
Okay. And then he also had a question of, can you stitch images together?
In the sense that, yes, it's called tiling, to where on a small machine, you can actually, and VCarve has an app for this, where you actually, if you have a long project, and I've done this, a 3-foot long project on a 2-foot machine, you can tile, called tiling the tool paths, where it outputs it in sections. So you move your board through and cut each section separately.
So if you had something that was like 4 foot long, then you could tile it.
It depends on, yeah. So if you have a 2-foot machine, I mean, I've cut 2 by 4 foot material on a 2-foot machine and tiled it twice.
Okay.
I've also, in smaller machines like that SD, I just did an experiment. I cut a piece of molding that was 4 feet long, and I tiled it 4 times, and I did 4 times, set it up 4 times. It's actually a pretty simple setup. You put a little guide board on the table, put a little pencil mark where you're going to start it, and then every time you move it forward by a certain amount, 10 inches or whatever the length of the table is.
Okay. And then said, oh, come on, CNC is real woodworking. It takes a certain skill level to make it happen just when power tools first came around. So it's a new technology that is part of the craft. I think it's pretty well said.
Yeah, very much so.
New technology that's been around a long time just seems to be coming around to the hobby shop home guy.
The question I used to get wasn't so much about being real woodworking, because in their view, when I got criticized for it 10 years ago, it was like it wasn't woodworking, it was cheating.
Yeah.
And I said, well, I tell you what, then go get the old buck saw out or go hand plane everything. I mean, I love those skills, but the fact is, most of us also have power planers, and we don't hand plane everything. Doesn't mean the hand planer doesn't have a place in the shop. Just like I said, I've got a whole selection of hand carving tools, and I still use them. But it's a combination.
Yeah. I'm a finisher, and so I look at it as in, like, spraying is really cheating, because if you come from a brush, that's how it used to be. There wasn't a spray, and now there's spraying. You don't want a brush.
That's
so
right.
It's the same idea. It's just an evolution of the craft.
Well, it doesn't take much Googling out there to see some of the really, truly creative and incredible stuff that's being done with CNCs.
Mm-hmm.
I think one of the challenges that comes in is the fact that if you look at the essence of a CNC really excels at duplication, because it takes a lot of work to set up the file. And some of us, I think, even myself for a first job, got a little frustrated with how much time it took me to set up the files just to cut one object.
Mm-hmm.
Well, if you can, the real sweet spot for CNC is routine or mass production even, So if you got a whole set of signs or a whole set of projects, that's where it really starts to get potentially fun and even profitable.
Yeah.
That's true. Well, so everyone knows, if you want to pick up Randy's book, is CNC Router Essentials. Woodworkingshop.com. The item number is S as in Sam, N as in Nancy, 34126. It is 30% off this week until the 23rd. So if you want to get yourself a nice resource to have next to the CNC in case you don't have the laptop, then this is a good way to do it. Well, Randy, we appreciate you joining us. We'll have Kyle jump in next, so you can stay here and we'll just kind of put you, back in the backstage, or you can leave and come back. It's totally up to you.
I'm going to hang out, but I can hide myself.
You can sit back there and heckle Kyle as he's talking.
Oh, I'm looking forward to Kyle. I'm a fan of Kyle's. I'll probably learn something.
Well, cool. All right. Well, thank you again, Randy, and we'll see you again soon.
Thanks.
All right. So, Mr. Kyle Ely.
Ooh, look at him with the fancy disco lights playing in the background.
Oh, yeah.
Wow.
We'll have a disco party later.
Well, Kyle joins us from learnyourcnc.com, and where Randy had mentioned a little bit about Vectric. Kyle actually has an entire package to where you can learn all the different parts of Vectric. It's kind of like a master course, if you will, and it's go at your own pace. And so, Kyle, tell us a little bit about how you got here, how you started learnyourcnc.com, and then, of course, how you turned this into a full-time career choice.
Yeah, so it was about last year, 2020. So, the pandemic went down. So a lot of people were out of work. So I had some free time on my hands and I was just in the Facebook groups, just helping a lot of people. And then I just made a quick tutorial for somebody and then people shared it and it just gained a lot of traction. So I figured, might as well just make some more of these. So I kept doing that. And then I kept getting the same questions over and over again. So I figured instead of answering all these questions the same way every time, I'll just make a whole video series, turn it into a course. And then that's how that grew. And now it's grown a lot since then. But basically just helping people out and sharing what I know.
Very cool. And then you do a weekly live in your Facebook group.
Yeah, I have a weekly live training. So that's like pretty much a virtual classroom. And it's held in a Zoom meeting where we can see each other if you want to. You don't have to share your camera if you don't want to, but we can see each other, we can hear each other, talk to each other. Students send in their projects and they tell me what they need help with. And then as a group, we go over that project. So not only does it help that person that needed the help, it also helps everyone in the group that has probably the same questions that that student has.
Okay.
Yeah, so between the master course, the weekly course, and the Facebook group, you stay quite busy.
Yes, I do.
Nice. So what have you got prepared for us today, Master Kyle?
Well, today I have this nice big sign I made, and I have a video that I believe I sent you, and it's basically going over how I created this sign in Vectric, and then how I machined it on the machine, and then also how I finished it.
And
So
I'm assuming you used your actual picture of your logo and converted that.
Correct.
All right. So this will be a great addition to what Randy did with the sort of bullet points. Now you're going to show how you took that image. All right. It's almost like we planned it this way.
Almost.
So I do apologize. You said there was a video?
He sent you a link.
All right, I'll send it. I think I could send it to you in the chat.
Check your
Sorry about that.
That's okay. I was looking to see if I had downloaded it, and I was like, wait, I don't remember seeing a video to download. So
I was wondering if you got it. Okay, I'm going to send it to you in the chat. Oops, sorry, that was the wrong link.
oh, yeah, that's the link.
That's
to
for this video.
Perfect.
We're well prepared.
Well prepared. Well, I'll tell you what, if you want to, you can just screen share.
I just sent it to you now. I don't know if that might be better if you do it. I don't know if it would lag if I do it.
Yeah, just click the link, Mike. You can join the show.
Oh, that's a good idea. Let me go ahead and do that. Thank you. All right, let's see here real quick. 1 second. I was completely prepared for this. Is that it? Yeah, that's it.
Well, I got to know Kyle a little bit by joining his Facebook group a while back, and last year I was so impressed with what I saw through communications with him through that I said, okay, we've got to have him be part of this extravaganza. So this is his second year enduring me and Mike on this.
Yeah, and I want to thank you guys for inviting me back. I really appreciate it.
Well, we can't believe you actually came back. Most people, we can't get them back, come back twice. So, you're either a glutton for punishment or you hadn't figured it out yet.
We don't really know which one it is, but we appreciate you being here either way.
Hey, but you got a video, so let's check that out.
All right, let's hope this works.
For this particular project, we are going to import the design that we want to cut. So there's a few different ways you can import. You can go to File, come down to Import, and you can import either vector files, which are 2D designs, bitmap files, which are image files, component or 3D models, as well as Photo VCarve, Machinist, or Cut3D toolpaths. So we're going to look at these first two here, vectors and bitmaps. We're going to look at the difference between both of these. And then you can also access this by your drawing tab there's a button here called Import Vectors, as well as Import Bitmap. So you can do the same thing from these two buttons here as well. And finally, there's one more way to import, and that's by actually going to your File menu within your computer, and you can drag and drop images or vector files right into your Vectric project, and that's another way to import as well. So you can see for this particular logo, I have two different file types. I have a PNG file, which is an image file, as well as an Adobe Illustrator file, which would be a vector file. So I'm going to first open up this image file. So I'm going to double click on this to open up in my computer, and I'll show you the difference between the vectors and the images. If we zoom in on this, you can see that this is made up of pixels. So image files are going to be a little bit blurry on the edges because they're made with individual little square pixels. And you can see any detailed items, you'll see these little pixels in all the corners there. So that's what an image file looks like. Now let's go to the vector file, which will be the Adobe Illustrator file. I'll open that up, and you can see if I zoom in on this one, this is not pixel based, this is vector based. So any of these lines are actually nice straight lines because they are vectors. And you can see I can actually turn these into lines within the program here. And you can see these are nice, solid vector lines that will import very nicely and cut very nicely. So basically what I'm saying here is the vector files are going to be the best source to import if you have a vector file available, but you may only have an image file and not a vector file available. So I'm going to show you inside of Vectric the differences between importing a vector file and importing a bitmap file. So here we are back in Aspire, and we're going to first look at the vector file. So we're going to go to Import Vectors, and we're going to open up the file that we just looked at, and you could see that will import right away as vector files. And you can see each line as individual, and these are pretty much ready to cut right away. You should not need to do too much to this unless you wanted to customize it in some way, or sometimes you may have to clean it up some. But in this case, this one's already pretty clean, so this would be all ready to go and create the toolpath. Although you'd want to size and position it first as well. And you can also see when you import it, it'll go on a separate layer, and it's now on this import layer, which is just the file name that you imported it from. Okay, so I'm going to go to undo that. So now we're back to a blank screen, and this time we're going to look at importing the picture. So for that, you would go to Import Bitmap and select the image that way, or like I mentioned earlier, you can open up your file folder, select the image you want to import, and then just drag and drop, and then it'll import it right away. Now we go into Aspire, and now you can move this around anywhere you want, as well as size and position it. Okay, so now you see when we click away from this, it kind of fades away. And if you zoom in, there's no 2D lines on this. So basically we have nothing to reference for our toolpath. So we need some kind of 2D lines going around the shapes that we want to cut. So in order to create our toolpath, we need to first create 2D vector lines tracing this image here. And you can manually trace all these lines, but you can see that will take some time to do all of this. So Vectric has a handy tool here called Trace Bitmap. And you can see it says no bitmap selected. So first we have to select our image. And with our image selected, we have two different options here. We can do color or we can do black and white. And in this particular case, either or will work. You could see we can adjust this up and down for minimum and maximum threshold. And you can see when you move it up, you will lose some of the colors. And when you move it down, you may also lose even more of the colors. So you want to get it somewhere in the middle there where you could see everything that you want to trace. So that is the black and white option. If you go to the color option, this will choose colors that are inside of this file, which you can see there's mainly 3 different colors, the white, yellow, and gray. So you can adjust this number of colors down to 3 if you wanted to. And that will get the main 3 colors there, gray, yellow, and white. And you can select a color. Let's say we selected yellow, and you'll see it'll highlight in red here, letting us know that's only what it's going to trace. So you can trace just the particular color that you want to trace. And another thing you could do is if we deselect that one, you can actually choose right on the screen the color you want to trace. So if we wanted to trace the white color, we can click on that, and you'll see that will highlight in red, letting us know it's only going to trace the white colors. And for this particular file, we're actually going to trace the gray color. So let's click on that. And we actually have to deselect the white color that we selected earlier. Okay, so now you can see the gray color is highlighted in red, letting us know it's going to trace all of this highlighted in red. And if you didn't like that red highlight color, you can actually change that color right here. Let's say we went to orange, and you'll see the highlight color will change to orange, which that highlight color doesn't really matter. That's just for a visual of what it's going to trace. And you can see with this color, it's going to trace the border of all the shapes. So that's the only color we need to trace. And then we have some additional settings down here we can adjust. And that is the corner fit. So how tightly you want to get into the corners. There's a noise filter. So if you had a little bit of a blurry image, it may trace some stray pixels. So if you turn this noise filter up, it'll reduce the amount of stray pixels that it traces. And then there's also the bitmap fading. And that's just the fading you see on the screen here. And this does not affect how it traces. So what you can do is click this default button here if you're not sure of the settings, and you could try it in the default modes, and then come down here, click preview. And if you zoom in, you can see it created a 2D vector line around all of these shapes. And if something looked off, you can adjust the settings down here and keep clicking preview until it looks the way you want it to. But keep in mind, you have to have a pretty clear image to trace. If you have a very blurry image, you may not get your expected results no matter how much you adjust these settings. So always try to find a nice clear image of what you're trying to trace. Okay, so I'm pretty happy with this. So we're going to click apply, and then we're going to click close. And now you can see overlaying our image, we have 2D vector lines now tracing everything that we selected. And we can also select the image, and you can see we still have this image in here, but that doesn't really do us much good anymore. So if we do not need that, we can actually either go up to our layers, and you'll see it was placed on its own bitmap layer when it was imported. So you could just click the little light bulb to hide it. That way you can get back to it if you needed to. But in this case, we really don't need it anymore. So we can actually just select it and click the delete key on our keyboard, and that will remove the image from our file. And now we're left with all of these 2D vectors outlining the shapes just like we had in our vector file. So now we basically just turned an image into vectors. And now we have something to create the toolpath to cut to. Okay, so once you get this far, you first want to check to make sure it's nice and clean. If you had anything you had to adjust, you can do further adjustments with the node editing, or you can use your drawing and editing tools to further edit this. But everything looks pretty good with this file. So what we're going to do is only adjust the size and position. So to adjust the size, we're going to select all of the shapes by drawing a selection box around the entire shapes. And we're going to go to our scale tool under transform objects. And the quick way to get to that tool is the letter T on your keyboard. Letter T for transform. That will go into your scaling tool. So with our object selected, we want to scale the selection. So we have that selected. And we're going to anchor from the center. In this case, it doesn't really matter where we anchor because we're going to move it afterwards anyways. But we can just leave it anchored in the center position. And then down here is where we're going to set either our width or our height. And for this particular design, we want to make sure we have our X and Y linked together. So make sure we have a check mark here. That's going to scale the width and height proportionally with whatever one you adjust. If you didn't have these linked together and you adjusted either the width or the height, it'll stretch or shrink in one direction and it will not look proportional anymore. So with our X and Y linked together, we're going to decide if we want to adjust the height or the width. Now in this case, we have 22 inches of height in our material to work with. So I'm going to take our height and I'm going to adjust it to 20 inches. Make it nice and even at 20. So you can see when I type that 20 in right there, it's going to automatically adjust the width proportionally to that measurement. So with our new height measurement, and that is in inches, we're going to come down here and click apply. And you can see it's scaled up to 20 inches in height from the topmost point to the bottommost point. and then the width automatically adjusted to 31.5 inches to keep the proportions correct to the original design. And since we anchored from the center, this center point is still the exact same center point that it was before. And you can see we can actually click here and move it to the right if we wanted to get it inside of our material. But we're actually going to use the move tool to position it exactly where we want it. So we're going to click close on the scale tool. And now we're going to go to the move tool. And that is the first one here in transform objects. And the keyboard shortcut to get to this is the letter M. M for move. If you type that in, that'll open up this tool as well. Okay, so now we can set our anchor position and our absolute position inside of our material. So let's say we wanted it 1 inch from the bottom and 1 inch from the left. We're going to anchor our position down here in the lower left. That's going to reference off this lower left corner of the bounding box of this shape. So that'll be this little dot down here. And we're going to go to the absolute position. That's going to be the absolute position within the rulers on the top and the side. And we're going to type in 1 inch for the X and 1 inch for the Y. And click apply. And you can see that will now move our shape. And now this lower left white dot there, that is one of the little handles there, is now in the exact position 1 inch from the left and 1 inch from the bottom. So that is how you can set the exact position of your design. So once we have that set up, we're going to click close. And there we go. Now we're basically ready for everything we need to create our toolpaths. We have our 2D vectors ready to go. We have it sized correctly, and we have it positioned correctly. And like I said, after we visualize the toolpaths, we're going to rotate this 90 degrees to make the longer measurement in the height, which is in the Y axis. But first, let's go to create our toolpaths. So to do that, we're going to go up to this button at the top to switch to toolpath commands. And now our toolpath tab will show up here on the right side. So now we're ready to create our toolpaths. So now the first toolpath we're going to create is the inlay toolpath. And like I mentioned, this toolpath is also available in Cut 2D and VCarve as well. So we're going to click on this inlay toolpath. And it's going to ask us if we want to do a male inlay or the female inlay. So the male inlay will be the separate pieces that we're going to paint individually and glue into these cutouts. So with this particular design, we would want to do the female inlay, which we're going to create a pocket for these shapes to fit into. So we're going to go down to the female inlay and we're going to select pocket. Okay, so next we're going to determine the cutting depths. And this first one here is the start depth. Now we're starting right at the surface of the material. So we're going to leave this at 0. That will reference all of our depths from the surface of our material. And next we need to determine the cut depth. So we're going to adjust this. And this is going to be how deep our pocket is cut into the material. So let's say we go 0.125. That'll be 1/8 of an inch deep. So that should be pretty good for this particular project. Okay, so now we have our cut depth. Next, we need to know what tool or multiple tools we want to use to carve this pocket. So some of these areas are going to be fairly large, so you may want to use a larger tool. But you want to be careful because the larger tool may not fit into the smaller areas. But you can, however, select multiple tools and use the larger tools to clear out the bigger areas, and then the smaller tools to fit in the areas that the larger tool cannot fit. But keep in mind that the smallest tool that you go down to in the female inlay is going to be the tool that you need to use to cut out the male inlay pieces. So you want to be careful of how small of a tool you select in this toolpath. So to select a tool, we're going to go down here to select. And that's going to open up our tool database. And we're going to come down here and select our 1/4 inch end mill. Now, everybody's settings are going to be different for the feeds and speeds. So we're not going to get into that in this lesson. But if you check with your bit manufacturer, you should be able to find the recommended feeds and speeds for that particular tool. Okay, so let's select this one. And you'll see that I'll place it in the list here, the 1/4 inch end mill. And with this tool selected, we can come down here and specify the strategy that we want to cut. So we can either do offset, which starts in the middle and works its way out, or we can go to raster, and that'll go at whatever angle you set down here in a zigzag pattern. Now we're carving MDF, so it doesn't really matter the direction that we cut. And I generally use the offset strategy anyways for a pocket type of toolpath. So this is the one I'm going to use. And with our strategy selected, we're going to come down here and we have an option to ramp the plunge moves. And if you do not turn this option on, it'll take your tool and plunge straight down into your pocket and start cutting away. But if you turn this option on by checking this box and setting a distance here, and I typically go double the distance of the diameter of the tool. So we have a 1/4 inch end mill, so that means it would be a 1/2 inch distance. That'll make it come in about a 45-degree angle. That'll now take the tool, and instead of plunging straight into your material, it'll come in at a slight ramp, and that just puts a little less stress on the tool as it enters into the material. So you don't have to use this option, but it does help your tool as it enters into the material. Okay, the next option we have is pocket allowance. Now, I always start at 0 for this, and I only adjust this number if my parts are too tight or too loose. So we're going to start off at 0, and we're going to cut this, and we're going to test fit our pieces. And if they're too tight or too loose, we can adjust that number and recut it again. But if you're using an expensive piece of material or a piece of material that you only have one of, I would recommend trying this out first on a scrap piece of material. It doesn't really matter which material you use, as long as you use the same tool that you plan on cutting the final piece with. You can figure out your pocket allowance so you do not mess up an expensive piece of material. Okay, so now we have this all set up. We're going to select our vectors that we want to cut. So I'm going to draw a selection box around everything to select everything, but I don't want that outside line. So I'm going to hold the shift key in and then click on that line, and that will deselect it. And now all the shapes on the inside are now selected and are going to be the only ones that are being carved with this toolpath. Okay, and then down here we can give it a name. So I'm going to do pocket inlay 1/4 inch end mill. And I can actually do female pocket inlay. And then we're going to click calculate. Okay, and you can see that created a toolpath for this. So we can do preview selected toolpath. And you can see that carved away all of the material in there. But you can see down here in the detailed areas, it did not carve because the tool is too large to fit in there. And we can see in this view, if we turn on the toolpath, you can see these lines in here are where the toolpath is going to travel. And you can see it did not travel in between these slots here. So that means we either have to adjust our design for the tool to fit in there or select a smaller tool to fit in there. So what I'm going to do in this case is add an additional end mill to this toolpath. So to do that, we have to edit this toolpath. And to edit it, you can double click on it and that'll open up the toolpath again. And then all we have to do is go to select here for a tool, select an 1/8 inch end mill, and then confirm all your settings and click select. And now you can see we have 2 tools in here. The 1/4 inch end mill is going to be the first one that cuts most of the material. And then the 1/8 inch end mill is going to come back and clean up the edges and anywhere that the 1/4 inch end mill could not fit. And you can see down here is going to be different settings you can set up for each tool. So the 1/8 inch end mill, it's not going to allow us to select a strategy because this tool is only cutting the edges. It's not cutting anywhere in the middle. But one thing I am going to change on this is the number of passes. So right now it's set up to cut in 2 different passes, and we're only cutting an 1/8 inch deep, and this end mill is only cutting along the edges. So I'm going to go to edit passes. That's going to bring up this little form here, and we could do clear all passes. So now it's going to do a pass depth of 1/8 of an inch. So I'm going to click OK. And now the number of passes is down to 1. And that's going to cut our cutting time in half. So now instead of going around 2 times, it's only going to go around 1 time. But just make sure your tool and machine could handle that depth of cut in 1 pass. Okay, so now with this new tool added, we're going to click calculate again. And that's going to recalculate that toolpath. And now if we zoom in, you can see already, we now have a toolpath going in these lines here. So let's zoom out. we're going to reset our preview. And you can see now we have two different toolpaths here. The first one is the 1/4" end mill, cutting out the bulk of the material. The second one is the 1/8" end mill, and that's going around all the edges and then also getting in between these lines here where the 1/4" end mill could not fit. But you can also see it took the same name for both toolpaths. So we have 1/4" end mill on this one and 1/4" end mill on this one. But this one's actually carving with the 1/8" end mill. So we're going to right click on that one, go down to rename, and then just change this to 1/8" end mill, and then deselect it. And now it's named appropriately for that toolpath. All right, so let's preview the 1/4" first. So we're going to select that one and click preview selected. And you can see it looks pretty similar to the way it did before. Now we're going to select the second one here and click preview selected. And you can see that one came back and cleaned up these areas that the 1/4" couldn't fit. It also went around all the edges to make the corners a little bit sharper with the smaller tool. So let's look at the 2D view. So we're going to go to our 2D view. And let's turn on these toolpaths. And right now we are looking at the wireframe view of these toolpaths. So this is the center line of where the toolpath is traveling. So we're going to look at the solid view by going up to the top here. And there's a button that toggles on the solid view. And now all these purple areas are going to be areas that are going to be carved by these toolpaths that are turned on. So if we zoom in, say on these letters, you can see we have a sharper corner here for the letter, but the toolpath cannot get into those sharp corners because the toolpath is round and it could not carve a sharp corner like that. But you can also see these corners on the inside here, it's actually cutting those away. And the reason it's doing that is because when we go to cut the male part, we're not going to be able to get into that sharp corner. So this inlay toolpath is going to automatically carve away these corners to allow a perfect fit of these pieces after we cut them out with the male inlay toolpath. So that is the difference between a regular pocket toolpath and an inlay pocket toolpath, is it will cut these corners away to allow parts to fit in there without having to chisel the corners or do any adjustments to the pieces. But just keep in mind your pieces will have a little bit of a radius corner. And the smaller tool you use, the smaller this radius will be. So we're using an 1/8" tool. So this would be a 1/16" radius corners. So that wouldn't be too bad in this particular case, because when you zoom out, you can see you'll barely even notice those little radius corners. Okay, so now our inlay pocket toolpath is created. Next, we would want to cut out this shape. So if we select this outer shape and we close our preview, and we can actually turn off the visibility of our toolpaths. Okay, so we have our outer border selected, and we're going to use the profile toolpath for this one. And then once again, we have to set up our depths. So the start depth is once again going to be 0 inches. So we start off at the surface of the material. The cut depth is going to be going through the entire material. Now, if you remember, we're just over 3/4 of an inch. So an easy way to figure that out, if you don't remember the thickness of your material, you can do the letter Z for the Z axis, which is the height, or you could do the letter T for thickness and then type in the equal sign. And that's going to automatically take the number that we set up in the job setup and enter that right here. And that was 0.775. So now that's going to cut all the way through our material. All right, next we have to select the tool that we want to use. And we can go to select a tool, but I'm going to try the 1/4" end mill that we used in the previous toolpath. So I'm going to do that one and click select. And you can see that's going to do 7 passes through our material. So if you do edit passes, you could see all the different passes it's going to do through the thickness of our material. And you can adjust these passes in here. You can set a last pass thickness if you wanted to, or you can do a number down here. Let's say we bumped it down to 6, and you'll see they'll automatically adjust up here. So now it will do 6 passes instead of 7. And then when you click OK, it will adjust the number here. And once again, you want to make sure your tool and machine could handle those passes So it's better to start off with more passes at a minimal depth and then work your way up when you get more comfortable with your machine. All right, now we have our tool set up. We need to know where we want to machine this line. So we can go on the outside of the line, we can go on the inside of the line, or we can go directly on top of the line. Now in this case, we want to keep the shape in the middle. So we want to cut on the outside of the line. That way it keeps that shape the exact size that we have set here. So we're going to select outside, and there's more settings we can do down here. One thing you may want to do is add tabs. So this will add little pieces of material left behind to hold the shape in place so it does not break free since we're cutting all the way through the material. But I'm going to be using the tape and super glue method to hold down the material. So I'm not going to use tabs in this case. And you'll see that when we go to machine this. But I am, however, going to add some ramps again. So we're going to click add ramps, and I'm going to do a smooth ramp with a 1/2 inch distance again. And that's just going to put a little less stress on the tool as it enters into the material. And there's more settings we can set up in here, but we're not going to get into too many of those in this lesson. So down here, we can go to the name of this. So we're going to do profile 1/4 inch end mill. And we have our vector selected on the profile there. So we're going to click calculate. All right, and it looks like it did fit in these smaller areas. So we know this tool is going to work. So let's click preview selected toolpath. And you'll see it'll do multiple passes until it cuts all the way through the material. And once you cut this out, you can double click on these little pieces in here to remove them, as well as this large piece out here. Double click on it, and now you can see what we're left with. And this is exactly what our piece will look like when we carve the first one here. And we can even change the material up here, and we could drop this down and we can go to MDF. So now we can see what MDF would look like carved like this. Okay, so this piece is looking pretty good. I'm going to say we're good on this. So I'm going to click close. And one thing I'm going to do is go to file and save. So we have all of our changes that we just made saved to our current file. And if we really wanted to, you can stop it just like this. So you can carve these pockets and paint inside these pockets whatever color you wanted, and paint the surface whatever color you wanted. And this sign would look pretty good just the way it is. But we're going to go for the more three-dimensional look by making the inlay inserts. So we're going to have to carve our 1/2 inch piece of material to fit into these pockets. So to do that, we have to make a new piece of material as well as new toolpaths for our shapes. And in previous versions of Vectric, you would have to create a whole new file to do that. But now in version 11, we can go back to our drawing tab. And on the left side here, we have a new tab called Sheets. And in here, you can add multiple size sheets within one file. So this makes it very handy to create files just like this, where we have two different pieces of material that we want to carve for one project. So you can see right now we have sheet number 1, which is, if we go to our 2D view, this sheet right here in white. And that is 58.5 inches long, 22 3/4 tall, and then 0.775 inches in the thickness. So we're actually going to edit the name of this by right-clicking, go to rename, and we'll name this one 3/4 inch MDF. Okay, so that's our first sheet. We're going to add a new sheet for our 1/2 inch MDF. So we're going to come down here to the bottom and click Add New. And you can see a new sheet appears inside of our sheet list. And if we zoom out, you can see it appears over here on the left. And the name of the sheet is down at the bottom. So we have 3/4 inch MDF. And right now it says sheet 1. We're going to change that to 1/2 inch MDF. Okay, so now that name changed in the screen here. But if you remember, we measured this piece of material and it's different from the size of the 3/4 inch sheet. So we're going to select that new sheet and we're going to right click on this and go to Edit. That's going to bring us into the same thing that we looked at in the job setup. So we're going to be able to adjust the size of the material, where we want to zero the Z and the X and Y. So we can change different settings within multiple sheets inside of one project. So once again, we're going to make the width the longer measurement. But before we save our toolpaths, we're going to rotate these to make the height the longer measurement. But just for visual purposes, we're going to make this width the 40 3/8 that we measured. The height is 12 inches. And the thickness is 0.516 inches. And I'm going to keep the 0 positions the exact same way as we did in the last sheet. So I'm just going to come down here and click OK. And you can see in our sheet list, we now have the updated measurements here. And if we zoom out, we can see our original sheet over here, the 3/4 inch MDF, and then our new sheet is the 1/2 inch MDF. So now whatever we design and create toolpaths for on this sheet will only be for the 1/2 inch MDF, and whatever we do on this other sheet is going to be only for the 3/4 inch MDF. All right, so let's go back to our drawing tab. And you can see we don't have anything on this sheet. So first we need some vectors to work with. So we're going to go back to our original sheet by double clicking on it. That's going to make that sheet active. And we want all the vectors on the inside here to be copied over to our new sheet. And we're going to copy these over because we want them exactly the same size, so we know they'll fit perfectly within the pockets. So once again, we're going to select all these by drawing a selection box around them, and then hold our Shift key and deselect the outer shape. That's the one we don't need. And now with all the shapes that we want selected, we're going to right click on these, come down to copy to sheet, and we're going to copy it to the MDF sheet. So when you click that, you'll see it'll move over here to the MDF sheet. So now we can double click on this MDF sheet to be able to edit it. And you can see we have the vectors over here, the exact same size and position that they were in the previous sheet. The only thing is they are now outside of the sheet because the sheet is smaller. So now we're going to see if we can fit all these shapes within this sheet. And these shapes don't have to be in the exact same position they are right now, because these are going to be all individual cutouts that we're going to glue into the pockets later. So it doesn't matter where these parts are exactly located. So we can either take these shapes, select the ones we want to move, and just manually position these within the sheet. And you can see if we do this pretty quickly here, we can just move these around. And we could probably get these to fit fairly easily, just like this. There we go. You can see you can get all those shapes inside there, and you can cut this just like this, and it'll be perfectly fine. Another thing you could do, if we go to undo to bring those back to where they were, you can select all of the shapes, and there's a tool called nesting down at the bottom. Now this won't be available in the desktop versions, but it will be available in the Pro versions and Aspire. So if we click on nesting, you can set the tool diameter, which is going to be the smallest tool that we use to cut out the pocket. And that is the 1/8 inch tool. So we'll type in 0.125. Then you can add a clearance between the parts. So I like to go about a 1/16 of an inch extra clearance. You can certainly do larger if you wanted to, but I go with a 1/16 to get the maximum usage of the material. And then we could do a border gap around the edges. And that's if you're using clamps or something on the edge that you want to stay away from. You can add an extra border gap there to give you room for clamps or whatever you want to use on the edge. Let's try leaving it at a 1/4 inch. Then we can rotate the parts to find best fitment. If you want the absolute best fitment you can go down to a very low angle, like a 1 degree, and that will position these the best way it can to fit inside of here. If you're concerned about grain direction or something, if you're using a solid wood, you may not want to rotate the parts. So you can turn this option off if you want the grain going in the same direction. Another thing you could do is mirror the parts to find best fitment. But if you do that, the finished surface will now be at the bottom instead of the top. So that may be a concern depending on what kind of material you're using. In this case, we're using MDF, so it would be okay to use that. Another thing you could do is allow parts to fit inside of other parts. And we're not going to use that because we want these entire shapes with nothing inside of them. And then you can also remove the original parts, or if you turn that off, it'll keep these original parts and create a copy of all of them and then nest them inside there. We can remove original parts if we wanted to. And then you can select where you want to nest from the anchor position. So we can do lower left corner, and you can go along the X direction or along the Y direction. If we had a boundary that we had to fit inside of, we can use a boundary layer in here, but we're going to use the entire sheet. And then finally, you can add additional copies of these shapes if you wanted to. Let's say you were making 3 of these signs. You can add 3 copies here, and it'll nest 3 different copies of each part inside of the sheet. And if it could not fit, it would spill over into a new sheet, and it'll automatically create new sheets as needed. Okay, and then we have our active 1/2 inch MDF sheet created. So we're going to come down here and click preview. Okay, and you can see it fit all those parts inside of here according to the settings that we set up. And they are spaced far enough away for the tool to fit inside of there. So you can see this may be a little bit differently than you would set this up manually, but this is a very quick way to get the maximum usage out of your material. And of course, you can further edit this afterwards if you wanted to. So if we're happy with this, we can click OK. All right, now we would be ready to create our toolpaths. So what we're going to do is go to our toolpath tab, and we can actually click on that and click the little pin at the top, and that'll pin it in here as well as looking at our drawing tab at the same time. So if you have to go back and forth, we can look at both at the same time. So we're going to select all these shapes, and we're going to use the inlay toolpath again. So let's click inlay toolpath. And before we did the female inlay pocket, so this time we're going to do the male inlay insert. So we have 2 different options with this. We have a straight insert, which just cuts straight along these lines, or you can do a stepped insert, which will create a little rabbit around the edges to overlap the pocket. That way, if you had a little gap that wasn't a perfect fit, that little rabbit will cover those gaps. But in this case, we're going to do the straight inlay. So we'll select that. So once again, we're going to do a start depth of 0 because we're starting at our surface. And our cut depth is going to go all the way through our 1/2 inch material this time. So if we don't remember our thickness, we could type in the letter T for thickness and then the equal sign, and that'll automatically insert the thickness for this material, which is 0.516 that we entered in our material setup. And then down here is a very important step. We have to use the exact same tool that we used for the female inlay, and that was the smaller 1/8 inch tool that goes all the way around the edge. And the reason you want to use the exact same tool is because the radius corners have to match up with the male inlay inserts. So we're going to go to select, and we're going to select the 1/8 inch end mill, the same one that we used before, and click select. And this is why I said beware of using a very small tool, because let's say if you went down to a 1/16 or even a 32nd inch tool, you would have to cut all these shapes out with that tool. So I try not to go much smaller than 1/8 of an inch, depending on the project. Okay, so we're going to use our 1/8 inch end mill. We can edit the passes if we wanted to, but this looks pretty safe for this tool, so I'm going to click OK. And this one's going to automatically machine on the outside of the vectors, so you don't have to select where you want to machine them. There is an allowance offset in here. If you were to cut the pocket first and then cut these out, you could adjust that allowance offset either bigger or smaller to make these parts a little bit bigger or smaller to fit inside the pocket. But I like to cut these shapes first with a 0 allowance offset and then cut the pocket second while still being on the machine and try to fit these pieces in there, and then adjust this pocket if necessary while it's still loaded on the machine. So we're going to cut these parts first with a 0 allowance offset. And these small pieces, you may want to add some tabs, but once again, I'm going to use no tabs, and I'm going to use instead the tape and superglue method to hold these parts in place. But if I was not using that method, I would probably use tabs because these parts are pretty small. But I just personally prefer using the tape and superglue method. That way you don't have to clean up all those tabs afterwards. Okay, so next we're going to add a ramp again, and we'll go with a 1/4 inch distance on this since we're using the 1/8 inch tool. And then we can also set the order that we want to cut all these parts. So we can do the shortest path. So we'll select that one, and that'll optimize it to go the shortest path between the vectors. And lastly, we can set the start at position, and I'm just going to optimize the start points to wherever is closest to the last shape. So with this all set up, we're just going to give it a name down here, and we'll do male inlay 1/8 inch end mill, and click calculate. Okay, and there you go. We see we have our toolpath created. So let's click preview selected toolpath. And you'll see that will cut through all of the material there, and it will cut out every shape there. And then we can double click on their waste to remove it in our preview here, so we can get an idea of what all these shapes would look like. So you can go through and double click on all that waste just to remove it. And these are the shapes that we'll be left with. And we can also see in our 2D view, if we turn on the visibility of this toolpath, and we're in our solid view again, and we'll zoom in, and you'll see any of these sharp corners, it's going to cut them off because it's going to match that radius that it cut in the female pockets. So if you remember that R we looked at, it cut away this corner in the female inlay because in the male inlay part, it could not reach inside there. So it automatically calculates for that. So now they're going to match up perfectly when we go to fit them inside of each other without any filing or chiseling in any of the corners. So that's the only toolpath we have to make for this 1/2 inch MDF. And now we're ready to go with our machining. But if you remember, like I mentioned earlier, we first want to rotate these 90 degrees to fit within our machine. Because right now my particular machine will not fit a board this wide. So I could either cut this down manually to make it fit, or I can rotate the sheet and the design to fit within my machine. And I would have to do that anyways for the 1/2 inch material, so I'm just going to do it for both pieces. So first, before we do that, let's save our project again, just so we don't lose anything. And we're already on the 1/2 inch piece of materials. And first, what I'm going to do is draw a rectangle around our piece of material so I know exactly where to place it when I rotate it. So we're going to go to Draw Rectangle, and I'm going to snap in this upper left-hand corner and then drag it down and snap to this bottom right-hand corner. Now we have a rectangle around our piece of material. So now we're going to click Close, and then we're going to go to our Sheet tab. And we're going to go to the 1/2 inch MDF. We're going to right click on that and click Edit. Now we're just going to switch the width and the height. So we're going to type in 12 up here, and we're going to type in 40 3/8 down here. And now you can see that's rotated 90 degrees. Now it's longer in the height and shorter in the width. So we're going to click OK. And now you can see our shapes no longer fit in this height. So now we have to rotate those. So I'm going to select all of these shapes, including that rectangle that we just drew. And we can either go back to our drawing tab and go to our rotate tool, or even easier than that, we can use keyboard shortcuts. And that is either the number 9 or the number 0. So with these objects selected, if you type in the number 9, you'll see it will rotate counterclockwise 45 degrees. And if you type it one more time, it'll go another 45 degrees, and now it will be 90 degrees rotated from the original position. So now with this rotated properly, we just need to center it inside of our material. And a quick way to do that is on your keyboard, the shortcut is F9. And when you click that, that'll go exactly center of your material. So now we no longer need this outside rectangle, so we can select that and click Delete. And now we have that entire design and material flipped 90 degrees from the original layout. But one thing to be aware of is if we turn on the visibility of our toolpath, you can see it's still the original way that it was before. Even in the 3D view, you could see it's now still horizontal, and we flipped everything vertical. So we have to adjust that as well. So we can either do that right now, or we can go back and adjust the other sheet first, and then we can do all of them at the same time. So let's do that. So we're going to deselect this toolpath. We're going to double click on our 3/4 inch MDF sheet, and we're going to do the same process. We're going to go to the rectangle tool. We're going to snap to each corner and then click close. And then we are going to go to our sheet tab. We're going to right click on the 3/4 inch MDF, click edit, and we're just going to switch these numbers. So this will be 22 3/4, and this one will be 58 1/2. Everything else stays the same, so we're going to click OK. Now we're going to select the rectangle and our design and click the number 9 key 2 times. So 9, 9. Now that rotated 90 degrees. And then we just need to center it by clicking the F9 key on our keyboard. And now it's nice and centered in our material. So now we can select that rectangle and click delete, and we can zoom in. Now one thing to note is now 1 inch from this right side instead of 1 inch from the left side. So if you wanted to adjust that, you can select the design right here, click the letter M on your keyboard. That's a shortcut to go to the move tool. And we can anchor in the lower left position again and just adjust the X measurement to 1 inch, click apply. And now we're 1 inch from this left side over here, which is from our origin point in the lower left corner. Okay, so let's click close. And once again, if we turn on the visibility of these toolpaths, they're still horizontal in the original location that they were before. So now we just have to recalculate all of our toolpaths. And there's a quick way to do that. You could close this preview, and there's a button right here in your toolpath tab that says recalculate all toolpaths. You can also right click on individual toolpaths, come down to recalculate, and you can either recalculate just one, you can recalculate all the visible ones, or you can recalculate all. So let's click recalculate all, and it'll tell you that it did it successfully. So click OK. And now you can see the toolpath is now recalculated to our new position. And we can go to the 1/2 inch MDF sheet, turn on the visibility of that one, and you can see this one has adjusted as well. So now we're all good to go. Everything should be correct now. So now we can save it one last time. And now our project is complete. Okay, so now that we have our project finished and our toolpath saved, we're going to head out to the shop and start machining this.
I want to thank everyone for watching. I hope you learned something from this video. And if you'd like to learn more on anything CNC related, make sure you check out my website, learnyourcnc.com, where I have an ever-growing list of CNC learning resources. And you can see I have some training courses as well. So if you want to learn more about Vectric software, I have the Vectric Master Course, as well as a live weekly training. And I also have one-on-one trainings available on my website as well. And if you just want some tips on CNCs and Vectric software, make sure you check out my YouTube channel where I post weekly tips and tricks, and they're very short and easy to watch videos. Thanks again, everyone.
Awesome. Where'd he go?
I'm here.
Oh,
Just
he's
my
there.
camera. My
He's
camera's
hiding.
not turning on.
Oh, okay. Okay.
I'll go with the backup.
You don't
camera.
have to be embarrassed. It was a great option, and we appreciate
There
that.
you go.
It was nice. Yeah. We'll have to get Mike in touch with you about finishing tips and tricks, though, because he's ragging me about how I spray aerosol a lot of times. Well, you should have been a little further over on top, and I'm seeing some marks there. And yeah. But no, great video, Kyle. We appreciate that.
Yeah, thank you.
Yeah, have you ever had any issues with the MDF swelling on you, especially when you paint it or try to seal it with the shellac to where it makes your pockets and your plug?
Yeah, sometimes they go a little bit tighter, but I try to leave a little bit of allowance for that, but it's never perfect.
Thankfully, MDF is very soft and sands real easy, so it's easy to
Yeah.
fix any sticky points.
Definitely.
Let's see. I think I saw a question pop up there, Mike.
There's a couple of little humana. So there, how did the second 1/8 pocketing tool know that it only had to go around the edges in the areas where the bigger tool wouldn't fit? Thanks, new to CNC.
Okay, so that's basically inside of Vectric. If you put this 2 tools in one toolpath, it will use the larger tool to clear out the bulk of the area wherever it can fit. And then wherever that tool can't fit, the 1/8 inch will come back clean up. And it'll also go around the entire border of the shape. That's just the way Vectric has it set up.
Okay.
Yeah, their developers are quite amazing.
Oh, definitely.
Well, if you guys are ready, we can start the CNC panel review. First joining us is Mr. Randy Johnson, who was here for our 1 o'clock hour. Welcome back. Oh, let's see. I think you're muted
How's the
somehow.
audio?
There we go. Okay.
All right.
And then, of course, if you don't know this gentleman here, his name is Frank. He's with Amana Tools. He is a character beyond characters.
Thanks for that.
But his
Well-
wealth of knowledge in tooling is unsurpassed by anyone. How's that, Frank?
Well, that's too much. Everybody out there knows more than I do. It's getting hot in here, boys.
Yeah.
Well, maybe you should get back to work on that air condition.
Oh no, that's fixed.
Oh, congratulations. Nice.
That's why I got this shirt on, because it's so cold.
Yeah, see, Frank is so good at his job that he had spare time to even work on air conditioning units and do maintenance and all the other things needed to keep Amana running smoothly.
Now it's electrical issues now.
Ah,
New outlets for new tables.
it seems to me like you need someone with a license in electricity to do that.
I used to have an electric company. It was called Surefire Electric. We wire for fire.
Oh, there you go.
It's one way they'll let you have the business.
Yeah.
Well, everybody's got to meet Randy, and we've met Kyle. So, Frank, tell us just a little bit about yourself and what you do for Amana, other than everything.
Well,
technical.
I'm the technical director for Amana. Pretty much answer all the. You know what? Let me just kind of put this. Hold on for a second.
I thought you were phoning a friend for help for that question.
What's my job title again? I
I
forgot.
was trying to do that. I was trying to think if I could with a do not disturb thing here. I guess they don't give one to me.
You could just unplug it.
Yeah, I was gonna say it's the plug in the back.
Yeah.
Yeah, well, no, they'll come running in. I don't want anybody to interrupt this nice meeting here we have here. So basically, I answer all the technical calls here, in relations to tools, in relations to saw blades, router bits. And, I get a lot of calls for, refrigerators and microwaves every once in a while, because people don't know the difference between a Amana tool and a Amana refrigeration company, I had 3 of them last week. That was pretty wild, mostly from really elderly people. So, and I've been here for 24 years and hope I make it to 25. I'll do that. Not a
We'll
problem.
see how today goes.
Yeah. Don't make a phone call, please, Chris, please.
I wouldn't do that. I've known Frank for a few years, and I'll tell you, he is a wealth of knowledge when it comes to tooling and just understanding of not just with all of the stuff that he has to deal with Amana, but he understands the CNC side very well in regards to proper feeds and speeds and depth of cuts and per pass and all of that. So I felt like, well, we definitely have to have Amana on, and they obviously have the name for quality. And then, of course, Next Wave with the CNC manufacturing, we thought, well, it would be great to have a manufacturer represented here as well. And then from the software side, we wanted to have something there. And obviously Randy covers all of that from his wealth of knowledge. But, Kyle, we've known him. So we thought, well, let's just put together a CNC panel. We can call it the A-team or whatever you want to call it. But nonetheless, we've got a panel here, and we love to answer any of your questions that you've got. And if nobody's got any so far, I've kind of jotted down a few that I get a lot, and we can shoot them to individual people. Oh, I got a good one for you, Frank. Don't you worry.
Well, the air conditioner just came on. I'm happy for that. I'm sorry, I don't know Randy. I have a rep named Randy Johnson. I thought that was going to be him, and I'm looking at the guys. You don't look like the Randy Johnson I know.
I used to play for the Diamondbacks, Frank.
You look much taller on the TV, Randy.
Yeah, that's true.
Yeah, you were a Yankee killer, weren't you?
Yeah, no, I get that every time I go through the airport. Hey, I thought you were taller than that. I just tell them no, but I'm better looking.
Yeah, that's for shit sure. And I'll stop right there.
Oh, man. Well,
No, Frank, you and I have crossed paths a couple of times. I've been around the block a few times, but never a lot of direct contact. But I was with American Woodworker for 12 years, so we crossed paths at a few shows.
It's funny that you mentioned that, because I don't want to say this too loud because the president's next door, but I kind of miss the shows for the people that you would meet, like a lot of the end users and stuff that would come up and say, hey, you helped me 5 years ago. I got another question. I says, call me back in 2 months, when I get back to the office. And they sure do. Here's my number, give them a card. And, now, I mean, IWF was closed 2 years ago. We didn't go to AWFS in Vegas this past year, although one of my regional managers went and walked around, and they said it was good because anybody who wanted to be there was buying something, but there was hardly anybody there. And then people from the manufacturers like us, they only took 1 or 2 people. So if 1 or 2 people are talking to 1 or 2 people, you're never going to get to talk to that guy.
I was there. It was I could see from one end to the other end in a single hall. Wow. And it's nothing like the old days. Yeah, I really missed. We'll get back to that, I imagine. But yeah, the old real handshake, face to face, nothing quite like that.
I know. I just got the thing for IWF before I was starting. It said, got to sign up for your rooms for next August. I'm like, you can see I was ripping my hair out today because I was out for like 2 days, and I just had like 40, 50 emails, and I get a lot of stupid emails, but that's
tell you what though, the innovators are not sitting still. There was some interesting stuff coming out. It's kind of incremental, but especially this whole world of CNC. Of course, you've been around long enough to see it from the beginning as well, and it's just half the stuff there is about CNC, and now people are starting to find how to apply it to other kinds of manufacturing process. In many ways, what we're seeing here is really just automation. There was good old Henry Ford started the assembly line, right? Now we've just added computers to that assembly line, and we've gotten smarter and smarter and smarter about doing it. So it's really just furthering the automation of producing stuff. And for woodworkers, it's come down to the level of the small shop now, which has made it really fascinating because, we all know some really creative woodworkers out there, and now you put behind them the ability to automate and, like the stuff Kyle just demonstrated. Go try and do that on a scroll saw. Totally doable. But most people would not take the time to do that. And
it's been crazy because you're right about that. Years ago it was like we were just selling tons of saw blades, but now saw blade, now more router bits is like we come out with maybe 100 new router bits every 6 to 8 months or so, and we're getting rid of the ones that don't move, and now everything is CNC. It's all ZRN coded. It's all Alton coded. It's all Spectra coded. And half of the woodworking tools, like, the profile cuts to do moldings and things like that, they're all going away, so to speak, roundovers, bullnose, if it's not selling, why make it? Because they're doing all this stuff with the 2D and 3D carving. And it's really a great thing, but you're getting these guys that have the little Shark or the little CNC that's like 24 by 18. And then you're talking to this guy, hey, I got a table that's 12 by 26 feet long. I was like, whoa. So, he's got a 20 horsepower spindle, and he goes, your speed rates are too slow. Your machine's too big, something like that, right? And the guy goes, yeah, I tried your speed rates. What kind of table you have? Well, I wasn't using a table. Duh, they're breaking, It is kind of nuts.
Yeah, it is. It's and I don't know where, it's one of the things that I'm sure, Kyle, you probably run into this too, is the fact that people like, well, when I get to the machine, doesn't it know everything I did in VCarve? And like, you have to set all that up, but there's still this disconnect between VCarve and machine operation.
Yep. And there's so many different machines. There's no one answer for all of them.
No.
I get that a lot. That Kyle's like, I don't have VCarve. I have, I don't even know the rest of the names. I know Fusion 360, and then there's a whole bunch of other, I guess, programs that go into, that different computers or different machines have. And sometimes Amana says, okay, you know what? You know your machine better than I know your machine. Let me know what tool you want to run. I can help you with that. But for these little guys, now, we get a lot of guys want to make signs for like the flea market. And with COVID, I guess the guys are building up for 2 years from now when they're going to come out with. You ever see that commercial for Geico? Live, love, and laugh. We don't need the sign. He throws that stuff out the window. Well, Geico's a big insurance company up here, so I guess in New York you still get emails. It's like these old people. They go to the store and like they start talking to everybody that they see, and the old guys that no, you don't need to talk to him. People saying that's you, Frank. It's like, hi, welcome to Walmart.
Oh man. Yeah, I know, and you hinted on this a little bit, Randy, when you were in your presentation about the feeds and speeds. And one of the things that I always talk to our customers about is, listen, every machine is different. Every manufacturer is different. Find out what they recommend as a max. And I personally, on every machine I've owned or ran, I run a test piece with a variety of feeds and speeds on it so that I can see and listen to what the bit's doing. And I found that to be very effective as a good learning thing for new customers to CNC. And it's just a simple test that you can actually visually see what the bit's doing to the wood. You can see the size of the chips, and you can certainly hear if it's screaming or if it's chattering to death.
Oh, yeah. Yeah. It's a topic I think a lot of people, it's important because as we know, if you don't run the right speeds, you risk messing up your project, breaking a bit, or just running too slow, you're just wasting time or burning up your bit. But to find that sweet spot, it depends on your machine and your setup. I mean, woodworking routers, at 30,000 RPMs, I mean, most industrial routers most cabinet makers are running between 12 and 16,000. And if you turn a woodworking router down to that speed, you're losing a lot of the horsepower and other complications. That's why that last picture I showed about the chips, I give people kind of a visual of what to shoot for, whatever machine they have. And I find, especially with the small desktops, whatever brand it is, if you can get close to getting something that is a chip and not sawdust, except you're doing MDF, that's always sawdust usually, you're kind of in the sweet spot. You're close enough. There's just too many variables in the small machines that you can't accommodate for. And the industrial people, like Amana and other brands, the numbers they put out there are geared towards more cabinet makers. So you have to take that with a bit of a grain of salt. So I try to get people off the analytical analysis of chip load pretty quickly and help them understand what it means, but then go back and say, okay, let's take a practical thing here. A few years ago, I was doing a big presentation out in Texas in front of a group of CNC people, and I was talking about chip load, and I was talking about the numbers and this and that, and this old guy in the back who'd been around CNC for a long time, 10 years. He spoke up and said, just make it sound right. And I looked at him, I said, you are exactly correct. What does sound right sound like? And of course, you can't describe it, but like a table saw, if you're pushing too hard, or your planer, if you're pushing too hard. And eventually with CNC, you learn that. So I think one of the mistakes we make, new people, and many of us probably still would get into seeing, because it's computer operated, we kind of give over to it and say, well, it's automated. I don't have to do anything. Right. No, you still need to pay attention because, Murphy has not left the room. He's going to come back and throw you a curveball and you're going to be in trouble. So, CNCs don't tell you what joint to make. They don't tell you what bit to use. They don't tell you what grain is going to do. Just another quick one. I was at a design school one time doing some training, and the students were very good with computer because they have a lot of experience. It's just a generational thing. We know that. But they had no shop experience. So when the wood started chipping out and cutting and didn't look like it would look like in the computer, they're like, well, why doesn't it look like it looks like in the computer? And I said, let's talk about wood, talk about materials. So I'm still a big proponent of people learning a lot of basic fundamentals about woodworking, because those people who have that knack with woodworking, that all applies to CNC. So it's really two areas of learning. So woodworking is still the foundation of it all. So
that's a good point, though. You're right about that. Is like, listen to what it sounds like. So when you've been doing this stuff for a long time, it sounds right. That doesn't sound so good. And these people, like, they call up and it's like, you're right. what Chris said is like they don't take the time. They get a CNC, they want to throw it on there, plug in the stuff, and it's supposed to run that way. And like you say, all materials different and stuff like that. I just want to add something to you, Mike. The last time Chris, you and I spoke, I was telling you about some of the things I have. Well, you got me now in the office. I just want to show you this. This, can you see this? This is a 3/4 inch shank bit. This is the way it goes in the collar. Can you see that? Right?
A bit, huh?
So the guy calls him back and says, "Hey, your bit's faulty." So it's like, if you can see here, you could see these two little see these two little tabs there. That's what that's sucked into the expansion joints of the collet.
Yeah, you
We
should
turned-
it that way.
We turned the machine on, and this is what happened. I was like, "What? Did anybody get hurt?" No. I was like, "You're lucky."
Wow.
That's one of those new right angle bills.
Yeah,
Yeah, there you go.
it's a 45 trim it, but it's 45 with trims on the bottom like this.
Vectric says they can't create a tool path to undercut. We've just figured out how.
Yeah, really. I'm surprised he didn't bust the vibration didn't bust the spindle.
That's incredible.
I know that's my like your piece in there. Oh, look at this. I got one. I was telling him, I don't know where that one is, but it was a bit like this, right? And basically, it was a 1/4 inch shank bit. It still had the wax on it, brand new, and it was bent at a 45, right? Just like that. And the guy says, "Yeah, we got it from the package like that." I was like, "Really? 5 people touched that. One person ships it from the factory, one person puts it in the pouch, one person picks it out of the pouch, then the other person takes it out, checks the numbers, puts it in a bag, and sends it." Did you have that in your router maybe and dropped the router before you turned it on and it landed on the floor? And that's what it's like. We get a bunch of that. But then I get some of the other ones, like here's one here that it missed a sharpener. It never sharpened, so it's just like the regular carbide blank in there. So sometimes the machine skips a bit,
Literally.
There's
skipped
something
the
in Kyle's
bit.
demonstration that people saw, but they probably missed the finesse of it. He was using an 1/8 inch bit to cut through. I think that was 3/4 inch MDF, right, Kyle?
Yeah.
I
only did the pocket with the 1/8 inch.
Okay, you went, well, how deep then?
1/8 inch deep.
Oh, I thought it went all the way around the side. You had a 1/4 inch bit going all the way around the side then. Okay.
Yeah.
So you didn't do any full depth with the 1/8 inch bit?
No, just the 1/4 inch.
Okay. But yeah, an 1/8 inch bit is you got to work with that carefully, but it's an amazing bit because of the detail, like that sign that he showed. You can get into those corners and do the cleanup. But if you don't get your feeds and speeds right, anything between 1/4 inch, I tell people it's all off the books. You just better be prepared to have a couple backups because you're going to, starting out, you're going to break a couple.
You mean less than a 1/4 inch?
What's that?
Less than a 1/4 inch diameter?
Yeah.
I got one for Kyle. You just mentioned MDF. A guy just called me up this morning. He had a 16th inch bit. Okay, down cut spiral, 16 inch, 1/4 inch shank, 1/2 inch cut length, and he was going into MDF. And he said, he was going in a 16 inch per pass. He was following the Vectric, on the Vectric thing that we had online, and he broke the bit, and he was pissed. So I was like, well, what we feed speed? Well, you got to understand, down cut. I say, down cut is a little bit different. You should try an upcut because this way it's getting the chips out. I know, Kyle, can you expand on that? Like with the down cut, it pushes the chips down into it, right?
Correct.
So
Yep.
should you slow those down more or not?
Yeah, definitely, because you're having all that chip buildup going down into the cut.
Right.
So if you're going the same speed you would with the upcut, you're most likely going to have some problems. So I generally go a little bit slower for the down cuts.
Is there a percentage you would say? Maybe?
I don't have a specific percentage, but I generally just bump it down maybe 10 to 20 inches per minute and go from there. And then kind of just like we said earlier, just kind of go from the feel it from there.
Right.
A lot of that too is based on the material. You said MDF. MDF is great for cutting, but on a down cut, it just takes that shavings and just packs it into the hole.
Right.
And you mix that up with heat. and you've just essentially almost like glued your sawdust back down into the hole with that. So
yeah, and especially, I mean, we go down. I mean, we even have like, I think, a 32nd or a 64th diameter bit for that stuff, and I'm like, please.
Well, the other thing too that I find, practically speaking, a down cut because of this packing issue. People say, "What are they good for?" I said, "Well, if you're cutting really thin material like veneers or thin plastics,
Right.
it pushes down on the material so it doesn't lift it up off the table." So, especially for the beginners, and I mean a lot of applications, I tell people avoid, unless you really have a specific application for the down cut, avoid it and try and use an upcut because it's just a better device. It's stronger. You're pulling on that bit rather than pushing up on it like that. And plus, you're talking a 16th inch diameter. I mean, that is so fragile.
With a 1/4 inch shank, no less. So you're it's always going to break right at the, I don't call it cleavage point or whatever, where it goes from little to big, It's crazy.
I did know a guy once that he had a poor man's vacuum table. It was he called it a poor man's vacuum table, but it really wasn't even a vacuum table. He would use a down spiral bit for everything, for plywood cutting, and then he would skip tabs. And that sawdust would pack between the parts so tight that it would keep the parts from coming apart. It almost acted like a tab. But of course, he's recutting everything with a 1/4 inch bit, and it's a mess when you're done. But it was his poor man's vacuum table, he said. So there's always a technique for it,
Frank, you guys need to come out with a 1/16 compression bit.
Yeah, right.
1 inch cut length.
There you go. We have one in an 1/8 inch.
Yeah, I have that. That's a fantastic bit.
You probably want a mortise one though now, because the upcut on that's a little high.
It's not bad for what you use it for. That's it.
There you go. What you use it for, it's not bad. But people use bits for what they're not meant to be used for in a lot of cases too.
Well, we can't help that. We're woodworkers. That's what we do.
I know.
Well, I don't have this bit that I really need, but I have this one. Let me just try it.
That was like, you don't have a chisel. Let me use my screwdriver. You ain't cleaning that corking around the window,
Yeah. Well, I'll tell you what, let's ask some questions here. Let's see. Kyle, I'll start with you since you're in the view here, top right. What do you like best about the new Vectric 11?
Hard to say,
but previous versions.
I like that sheet option that we just looked at in the video. Before, I'd have multiple projects going on, and for one project, I have multiple files open, and it's so much easier just to have it all one place. You can have different sizes, you can have different zero positions, and I think that's probably my favorite feature of the new version 11.
Okay, and I guess with that in mind, I know you're teaching on Vectric. What do you like best about Vectric compared to some of the other programs that are available?
Just because it's so popular, almost everybody's using it. So you can almost find help anywhere. You can find a lot of information on it. It's very good. It's just like a universal software that almost everybody uses. Sometimes when you get software that only one in every few people use, then you have a hard time getting questions answered and stuff like that. So I just like the usability of it, and just very simple to use too.
Yep, that's probably my favorite. Is it's very user friendly compared to other programs, and it's easy to kind of learn as you go.
Another thing I like is like I use Fusion 360 sometimes, but almost every week there's an update and it changes, and then you have to relearn how it uses, stuff like that. So Vectric almost stays the same all the time. They just add new features, but the layout, everything, the icons, nothing changes. So that's another great thing as well.
Gotcha. Well, Randy, if you are a new person, someone looking to get into CNC, maybe you list the top 5 things you would look for in a CNC, or that you would advise them to be educated on before they get into CNC. 5 things to look for in a machine.
Sure. As I mentioned previously, I think for a lot of people, the budget is a big part of it. And it's all going to be personal there. But, most people I talk to, it's a pretty significant purchase, because let's look at say a 2x2 foot machine. That's the price of a table saw or more. And so that's a significant purchase for most small shop or hobby shop people, and that's the one market if you're in that market. So within that, you definitely are spending some money. So a lot of the machines you start out with either will come with like the router spindle decision. You can save, I don't know, $500 to $1,500 depending on the product, the type of machine you're going with, by going with a router rather than the spindle, and you can always upgrade. But clearly an upgrade to a spindle, especially if you're in a small shop or a basement shop, or I've had guys talk to me here in their bedrooms, even out in your regular shop, that machine is going to run for dozens of minutes or several hours at a time. And that router continuing like that gets really old listening to. So that's one thing. Definitely, if you could afford the spindle, get the spindle. Secondly, the travel distance. I mean, you got to be somewhat practical about that. You can always upgrade. There's a good market out there for used equipment. I've been following it, and you're not going to get full value out of it, but like a used car, you're going to get some value out of it. You can always trade up, and sometimes that's a better option, because the one thing you can't do with the machine is really increase its bed size. Once you get it, you're really kind of strapped into that. So if you think you're going to be doing larger projects, you have the room in your shop, going with a slightly larger machine makes sense. The other part, again, is the pendant side of it, or the control panel side of it. There are some machines on the market that use a type of controller which is common to several machines. There's some Chinese machines that come in. There are some machines that are made in the US that have a certain type of control system. I'm only saying certain because there's several control systems out there. But if you have a chance to work with somebody who has the machine and ask them about the control system, how they like it, because some have pros and cons. I have, like I said, I have 4 different machines in my shop, and each one has a different control system on it, and each one has its pros and cons. If you can run a machine either off your computer or off the control pendant, that brings some advantage, because there are some projects it's nice to do it one way or the other. Sometimes if I'm working on a project that creates a lot of updates, like Kyle mentioned in his VCarve class, where he will cut out the letters and then cut out the pockets second. And then you saw him checking how he was seeing if the part fit in that pocket, but the board is still in the table. So if he doesn't fit, he can then go back to his software, cut a little larger. That's one of the times, if I have a project like that, I like to have my laptop right in my shop. So then having a machine that you can hook your laptop up to right to your machine is handy. So that's something to look for as well. Spindle power for most of the small desktop machines, it's surprising. Like I said, it's the spindle is a better choice over the woodworking router from a noise standpoint. From a cost standpoint, you have to consider that. But you can do a lot of work with router spindles. I've seen guys do amazing amount of work even with the small Colt type router. So I guess a lot of that comes back to price. When you buy up on the software, I always tell people start out with VCarve. You can always move up to Aspire, but Aspire is a little like learning Photoshop. And from my experience, only about 20% of the people who buy Aspire really understand its power. And VCarve has become so powerful. Some of the things that Kyle pointed out in his presentation, unless you plan to do your own 3D modeling, there's almost no need for Aspire. Now, Aspire has a few other features that are really cool, and I use it a lot. But generally, when you're starting out, a VCarve, that'll save you some money too when you buy a machine. Any other aspects of machines that you've wondered about that you're curious about?
Oh, no, I get a lot of these questions at work, and so those are some of the things that a lot of the same things I've pointed out, and we deal a lot with people wanting to buy some of the cheaper belt driven machines, or when you get into those questions, and always lead them towards something with a screw as opposed to the belts. And weave, and the dealing with the belt, sometimes you got to deal with the slippage and stretching and breaking, and whereas a lead screw, typically you have much a much more consistent operation. And because I get that, the second phase of that question I get a lot is, well, why would I pay this when I can go get this? And so then you have to learn to, okay, well, here's what you're going to get with this machine. Here's what you're going to get with this machine. It's not that one's bad or one's good. It's good, better, best, and helping
Well,
them
see, you're
understand
coming
that.
back to price. Of course, you're in the selling business, so price is a big deal, but it is a big budget item for most small shops or hobby shops. And that's why when I start out, if you could afford to push yourself a little bit, step up to something kind of on the desktop, kind of the mid-size if you can, or be prepared in a couple of years to upgrade. But it is a major investment. So price, and then once you get at a price range, then you start having some apples to apples you need to start comparing. And it's never ending. You go all the way up to you can very quickly end up with a $20,000 machine that is meant for a cabinet shop when you really can get by with maybe a $5,000 machine.
Oh, yeah. And I get a question a lot. Well, am I going to recoup my money? Well, I don't know. What are you going to do with it? Are you making projects for your grandkids, or are you actually trying to make things to sell? And if you're going to make things to sell, well, what are they? Well, I don't know. Well, then it's unlikely you're going to recoup your money anytime soon. Now, if they come in and if you've got grand ideas in these really niche markets, there's a lot of potential to recoup money when you're dealing with CNC. So, just fascinating conversation. And some of the things that I get questioned, I figured I would just ask you, being in the industry.
Well, that's actually an excellent question. Do you intend to use this to make money, or is this just strictly a hobby?
Mm-hmm.
If it's a hobby, then it's a personal choice. But if it's for a business, it depends on your business plan, but there's definitely a chance to recoup it. I mean, I'm always really impressed with the kind of widgets that people are making on their CNCs and making a go of it.
Mm-hmm.
There's a company out that Next Wave works with, and they actually have 20 of their machines. I think it's 20 set up in their shop, and they make basically control consoles for the gaming industry out of wood and all these gadgets to put their electronics in. And they've got every machine set up to do a little different phase. So rather than buy one industrial machine with a tool changer, they set up 20 workstations, and one does the covers, one does the buttons, one does the bases, and they just crank these things out all day long. And it's part of it's the strategy of how you're putting your parts on. That's why I tell people, if you're going to do kind of production signs, yeah, sure, get a big machine, but plan to do 4 signs at a time, not just one at a time.
Right.
That makes sense.
Yeah, good thoughts.
So I will throw this out there that right now getting a router is kind of a little bit more difficult than it has been in the past. So a spindle might be a good option. And with that option, Next Wave Shark, the HD 510 and 520 will get you a free 2 horsepower spindle with the purchase until December. And then with the Extravaganza, there's an extra 10% off the machine on top of that. So if you're thinking about getting into CNC, now is the time to really save some cash, get that upgraded spindle, and get to work.
That's right. And the Shark HD series is a very good line to get started. Good price point, solid machine. Like that heavy duty aluminum gantry and the aluminum top, lots of T-track and hold down capability. So, and that spindle's what, about a $900 value, $800 value?
Yeah, $799. So, I mean, I'm looking at here, $1,200 savings for the 25 by 25 for the 510. So that's pretty good.
Yeah, it's a huge value, and it's a great performer too. That's what I have on my machine, is that 2-horse spindle, and done a lot of cutting with it.
Yeah, and whether you go with a spindle or whether you go with a router, they both accept Amana bits, which is also on sale right now.
Frank, hey, Frank's turn. Hey. But so, I do have a question on this one, though. Speaking of routers and spindles, do you think there's more vibration in a router in a CNC or versus a spindle due to the fact that, one's on brushes and it's on, spinning armatures? What do you think, Frank?
Oh, me?
Sure.
Oh, Jesus, right. Yeah, probably you're better off with a spindle than you are with a regular router, I would think. And then you got more power with the spindle than you do with the regular router. And then who knows how they connect in the routers in there. the vibration, it can move it. And when you put an extension, because they have to reach on some of these things, every time you add something to it, it's the concentricity is going to get a higher tolerance or lower tolerance, whichever way you're thinking about that one.
Yeah, those issues get, the bigger the machine, the bigger the motor, they all become more of an issue. I worked with a couple of shops that were running, I think they were 3-horse Porter cable routers on their CNC, and this was a full-size CNC. And they actually had 2 of them in backup, or basically one, because one of the downsides of a woodworking router is that the bearings will last, I've heard, somewhere around 400 hours. Okay, so that's 10 weeks full time if you're running your machine, or it's 20 weeks half time. Anyway, this was a production shop. So they were burning up a woodworking router about every 6 months. And the bearings were going out. And when the bearings start to go, the bit starts to wobble and you end up with bad joints. And it's not the machine's problem. It's not the bit's problem. It's the bearing. And it's not sudden. It's gradual. So at some point, the amount of run out they were getting was making inaccurate parts. It was putting wear on the bit. It was causing chatter and all that. So they would swap it out with another one, and they kept swapping them out. And that was their routine. They would go get it rebuilt for, I don't know, a couple $100, but they were cheap. They didn't want to spend $1,500 on an industrial spindle or 2,000, whatever. So I did a little research, and a lot of spindles, one spindle manufacturer I'm aware of, they guarantee their spindle for 2,000 hours. And that's guaranteed. And some of them, then at that point, you can have the bearings rebuilt, and sometimes you can't. So there is this aspect to where a spindle, unfortunately, even at $1,500, is a toss-away item. Better to buy it than have it rebuilt. Now, you go up in price, industrial level, $5,000, $6,000 spindles, those you can rebuild those. But the other thing about a spindle over a woodworking router has the advantage is that the run out starting out of the gate is much less. It's very high precision bearings. You're going to have less run out to start with. And then there is this other part where most spindles are designed when you run them at a lower RPM, you actually don't lose torque. Where some woodworking routers, when you run them at a lower RPM, it's almost proportional. Now, I'm not an electrical engineer, but this is kind of the common discussions I've had with people, like a 3-horse router, you run it down to half RPMs, and now you're down to 1.5 horse power. So some of that is a bit of an issue, too, and the other advantage of a spindle.
Oh yeah, there's a word I was looking for run out. It's the worst, because once you start running out, it just ruins your whole project.
Yeah, and I think one of the bigger advantages to the spindle, in addition to what you guys talked about, is they run off of a better collet system. The spring collet style that is made and designed for spindles tends to be a little more intolerance to what is designed for a CNC. A lot of the router spindle or the router style collets tend to have a little bit more movement to them, and they're not quite as consistent with their
sloppy. They were made for doing stuff on a job site, at one point, or doing like cabinet stuff. So, the tolerance for kitchen cabinets, I shouldn't say this to offend it, but sometimes it's, if you're building a house or you're building a watch, you got different tolerances inside of, different things, and everybody wants the tightest tolerance possible, whether it's a dado cut, whether it's a through hole cut, or whether it's a drill hole. You
don't notice as much in handheld routing because a lot of the bits you're using are bearing guided, so that basically eliminates the run out. Or if you're doing a dado or a groove, you're running a couple of slots to fit your odd size plywood, and you just move your guide board over till it fits. You don't even think about run out. Plus, you're not putting the dozens and dozens, hundreds of hours on a typical handheld router that you do on a CNC. So, it gets the job done, but those are some of the downsides of a router on a CNC.
But I guess it's a significant cost savings on some of those small routers, like the Shark. Was it the Shark that has that, what do you call it, laminate trimmer on it?
Mm-hmm.
Yeah, they're small models. You can run a Colt laminate trimmer on it. You can.
Well, that was the first one that most people, they say, I got a Colt laminate trimmer. Well, this is not the 1/2 inch bit for you. No, I can only use the 1/4 inch,
Yeah, and I'd even had a conversation with I believe it was the one of the sales manager from Shark about in most of the small scale units, that's what they use are the laminate trimmers. As I said, you get into a situation where someone might be wanting to use it at a lower RPM. You get real limited when a laminate trimmer's in there. Most of those you're stuck at 18,000, 15,000 RPM is the lowest option. So you just got to understand what you've got and what tool you're using. But when it comes to bits, we sell a lot of the Spectra coated. So Frank, why don't you sort of elaborate a little bit on the difference between the Spectra versus the ZRN? Why the coating and what are they for? Help our customer understand.
Let me tell you. Okay. The ZRN coated adds lubricity and it protects against heat when you're cutting aluminum. That's pretty prime for aluminum. It's pretty simple. And the Spectra coating was more developed for the woods and the plastic because that's a ceramic coating. So it helps, dissipate the heat. It adds lubricity. And that's what it's all about, to make the carbide or the bit last longer when you leave it too long in the cut. For these newbies, I guess, if they're not going fast enough, they're saying, yeah, it's good. It didn't get hot, but it still broke. Well, you were running it too slow, but it still didn't heat up, which is a good thing. But we had a guy testing it. He built his own 2 machines, some guy out on the island he made boards for radiant heat. And this guy is a brilliant engineer. He built 2 of these machines, and he came and he used to buy the regular bits that were uncoated. And then we came out with the coated bits, and he bought a couple from one of the local guys out here. And he ran them like for a couple of weeks. And he's like, wow, he goes, and that's why that Spectra bit lasted 5 times longer or more than the regular uncoated bit. So that's when we started to coat that stuff, and it kind of really took off. We put 2.5 times the life or 2 times the life. So, for an extra, and I'm just throwing numbers out here, $10, $15 a bit, you're getting twice the life out of that, and they can be sharpened. They all can be sharpened. So, yeah, you might not get a little bit of coating on the edge, but it's still inside the flutes to eject the chips, and it helps protect the bits from the heat.
Well, I want to throw a plug in for one of your bits, Franks, that I've been using for a couple of years is the insert bits.
The insert tools.
In particular, the V-carving insert. You guys have one, I think it's like 11/16 inch in diameter. It's a 90 degree, just a little over a ½ inch. It's effectively has 4 cutting edges because you can change it, and it's effectively a single flute. And the things that Kyle mentioned about fluting apply here with chip load and the stuff we've talked about. That I absolutely love that bit.
It's not the in-groove system, is it? Is that the one where you could change the different bits? You go 30 degree, 60 degree, 90 degree.
Oh, I can't change the angle. It's a single angle bit, but I can change the cutter. It's an insert cutter that I can change out on it.
Oh, and it flips 4 times.
Yeah.
45, 711 or something. RC 45, 711, something like that.
Yeah, it's and the replacement is like, I don't know, $7 or something for that bit for the insert. So it's actually more economical than using a regular.
Actually, it's actually, you can see that right back there. It was the Intech.
That sounds familiar.
And we had like about 9 different tools. Let me get it. I'll show it to you. I got to clean some off here first.
And I'm sure Kyle can attest this too. When you set up a V-carving in V-carve, you say this perfect V-cut, but your V-bit has to match that because some bits of the market don't have a good tip on them, or I call them a shovel nose on the tip, and you get a screwy cut.
Yeah, we did.
Yeah, that was from the show. There's like 9 different bits.
Anyway, that 90 degree V-bit has become my favorite V-bit bit at this point.
I got the number right, Chris. 45, 711.
Are you? Why don't you bring that back and just hold that up for the rest of the show?
I feel like remember in Die Hard, the guy walking around, Jesus save Zeus.
Frank.
Oh man, this guy.
It's all right.
But no, they that's that's another thing is when you're dealing with these bits, Amana has really, as far as I can tell, has just really launched and started a movement on the insert tooling.
I mean, this is the latest catalog. Look at all the different tools you have here. You know, you got this one here. No, this one here is the in-groove system where you can change out these knives. You know, you got four board cutters, V grooves. There's
I've got that one too.
Here's this other one is good. Here is all the no more bearings.
Love that bit too.
That one there. You know, they're all different sizes for the drill bits and the drill countersinks, and there's a bearing in there, so it comes down on the wood. It doesn't mar the finish of the wood. So, and then like I said, there's all the woodworking bits. But the CNCs are just like, it really taken off. So I kind of say, I don't say saved us, but that's been the biggest growth so far in the last couple of years. It's all CNC. I mean, you think about, let's see, they didn't have it, 4. About 6 years ago, you saw 1 or 2 CNCs at IWF, maybe 3 or 4. The last couple of years, they're all CNC. You don't see those big, jibbing panel saws and things like that. They're all cutting because they can nest things together. Mm-hmm. Now you're nesting, you're saving so much. There's less waste. There's more cuts, profiles getting done. And like you said, you're not making one like sign, you're making 4 to 8 signs or 12 signs, whatever, on a 4x8 sheet. So, guys putting they're putting those sheet down. He's going away. I was in one place that it was kind of neat. They had a 4x8, or maybe it was 5x12. But what happened was the gantry would come down and it would cut this. Then it would go down to the other side. The guy would put a sheet on that side. Then he'd peel all this off, put another piece of plywood down or whatever it was to cut. Then it was almost timed perfectly. And then the machine would come over, cut here, he would move that. And that's all he did, went back and forth. Sometimes they had 2 machines, next to each other doing that. I mean, and they're just pushing out all this stuff. And even like you say at the Vetric show, these guys are coming around with these little tiny things, making that calendars and little gears like keychains and things like that. And it's like the most minute detail, and you're like, wow, you couldn't do that by hand, well, guys did it back in, but they had a lot of time. Now we're all so busy, very busy, very busy.
Mm-hmm. For sure.
It is.
Well,
so is there anything in the research and development department you can tell us about that we're not supposed to know?
No.
Okay. Nobody's listening. Trust me. We're all alone. Just us 3. Just us 4 guys here. Come on.
Just us 4 guys, right? Nobody.
Yeah.
Well, I can't tell you that.
You could just say yes or no.
There's always
they probably keep him in the dark.
Yeah.
He said the president's sitting next to him in the room next door. He can't say too much.
Wait a second. There must be a microphone in here someplace too,
Gonna find out. Hear some banging on the wall. Like, all right,
Mike, you shouldn't have said that. You're wrong. You didn't say run out right away. I was tongue-tied. I got confused. I'm sorry.
Oh man.
What kind of blade do you use in a radial arm saw? Radial arm saw blade. It works.
Yeah, they're circular.
We have them,
They can have a negative hook on them, right, Frank?
Oh, they do. Hey, what's really funny about that though is like sometimes I lose my train of thought, and I just did. But it gets. I'm honest. What can I tell you?
Great example.
A great example. I know. It's just like there's just so much stuff that comes up so fast. It just gets pretty nuts. Pretty nuts. Man. But so Mike, tell us, what are you up to lately?
I don't know. trying to keep this show together somehow.
See, now you know how it feels at the other end.
Oh yeah. No. That's why when I don't know what to say, I just throw it at you like, Frank, what's pink papers in the background? What you got going there?
Those are return files.
Oh, that's not a very big stack, so that's good.
No.
That's just
the other three. There's not that many. But the thing is like when I need to find one, somebody says, "Hey, did you do this?" I just look for I had this system coming up when I have a return or an order. I just keep it one color. Nobody likes pink. So I figured that pink is easy to find out with all white papers in there. So you go, oh, this is mine. So I don't waste no
Hey,
time.
I've got a question for Kyle.
Yeah.
So Kyle, you showed us your CNC sign, which by the way, you did a nice job. I could tell you, you know what you're doing, and you don't have to, you definitely do.
Thank you.
What other projects? What's one of your favorite projects you've done this past year? I'm curious.
This past year, I haven't done as many projects as I'd like because I've been doing a lot of training, but
Oh, got it.
I would say my all-time favorite project was this custom desk I made. It's like a solid oak desk, and it had many different curves on it. It's in a building in New York City right now, but it turned out really good. It was very challenging to get it, but I did it all in VCarve.
Oh, so it was a CNC project.
Yeah.
Yeah. Second question: how did you get into woodworking?
I've been in woodworking since I was probably 12.
Okay.
My grandfather kind of showed me it, and then I got a scroll saw for myself, and I just went crazy with making stuff with the scroll saw, and then got watching videos online, and I'm like, hey, there's CNCs out there. That seems better. That seems easier than a scroll saw. So I was around 16 when I got into CNCs, and then
Tell them where you built it, Kyle.
yeah, I built my first CNC in my bedroom when I was 16. So made
Did you have to clean up the mess or what? How'd that work out?
yeah, it was a little messy, but it's a good learning experience.
You're sleeping on wood chips. Oh, I like this. It feels good, you know?
Yeah. I eventually made myself a shed to put it in.
Attaboy.
Well, given your age, and you look around the room here, at least I'll speak for Frank and myself. You're one of the youngest woodworkers out there right now, probably, and so welcome to the gang. And you'll carry the banner after we're history. So, and you got a good foot start, really, with the whole CNC stuff. So you got I mean, when I was doing the magazine, like I said, CNC was so new back then. People were like, "What's CNC?" You had to describe to them what it was, and but I told lots of high school kids at that time, because I used to do a lot of work in schools. I said, listen, if you want an interesting trade, go into CNC. You know, either metal machining CNC or woodworking CNC or design. I said, if you want to do something that has to do with building stuff, go that route. And it's still a great opportunity. So I'm up here near Minneapolis, and there's lots of mill shops and machine shops. They're just crying for CNC programmers and designers and machine operators. So it's an incredibly developing trade for that.
Definitely.
You know, it's funny you mentioned that, Randy, because when I came to Amana 24 years ago, there was really no CNCs in woodworking. But I previously came from a plastics fabricator, and they had a lot of CNCs in there cutting up like, G10, G5, all phenolic boards, where it was all military contract and stuff like that. And I know there was a lot in the metalwork, and, there was lathes and bridge ports and things like that. And they just expanded that stuff. And it finally got into woodworking, like you said, and now it just keeps growing and growing and growing.
Well, and I think, we talked earlier about like what's new coming down the pike, and what, how the big technology is coming downstream to the small shops. I saw something at a screen. It was really a printing company. They bought a machine to cut some, they were cutting sign stuff. So much like what Kyle just did with the MDF, they were cutting foam board, all kinds of stuff. But they had a machine that was cutting out letters out of vinyl. So get this. So they take a big sheet of vinyl and they print on it, like 5 feet wide by 10 feet long. They lay this on top of a CNC machine and stretch it tight. And then they take a CNC machine with a knife in it to cut the parts out.
Drag knife.
Well, essentially, that's exactly what it is. Now, this is a high-end industrial version of that. But you know what happens when you stretch fabric? It stretches.
Right.
So the fact is that this design was getting stretched, but the Vectric file, what Kyle just showed us, doesn't match up with the printing any longer. So they have cameras on this thing that register to registration points that determine how much stretch occurred, and then it automatically adjusts the cutting program and stretches the tool path to fit the lettering.
Wow.
Now, we don't really have that needed woodworking, but that kind of onboard camera, infrared, and all that kind of onboard camera stuff, someday, I mean, already on some of the big industrial stuff is there, but someday I see us getting to the point where with even the small shop CNCs, we're going to have an onboard camera that rather than zeroing out the XYZ, it's going to use like, I don't know, laser or sonar or something to zero out the surface of the material, go find the four corners, and your zeroing is done and automatically register your V-carve. We're not there yet, but I do see something like that coming our way.
Sure, the guys will cut it and they'll be home working from home because COVID will be all over the place, God forbid. And it's like, oh, we don't need this. They have that in the saw sharpening and router bit stuff. They just load it in the thing and they go home. If, after it's done, it flips the blades onto another spindle and something. When it's done, that's it. If there's a problem in the middle of the night, it'll call up your cell phone and say, hey, you got a problem. You better get down here and switch out the carriage or whatever. But that's pretty neat.
Well, the woodworking industry at NWFS, there was machinery there that was auto loading and auto offloading sheets of plywood.
Right.
So, taking this automation to a whole new level where you don't even have guys lifting sheets of plywood onto it.
But we'll still sub it out to China, right?
Yeah.
I know the CO2 lasers have the cameras in them now, where you could position a part in there. Maybe it's like a circle.
Yep.
Put it in the bed, and it'll have the camera on there. You just place it on the software while you're viewing the camera, and then you can cut it right in that circle.
That's cool.
I don't know, officer. My wife went into my shop, and I don't know what happened, and the thing just cut her up. I don't know.
So you're saying Amana doesn't have a laser bit?
No.
Yeah, pretty much when people tell me they want to cut with something smaller than an 1/8 inch, I typically say go get a laser.
I've seen a lot of that in the shops now. They got the laser for cutting plastics and stuff like that for a lot of the display manufacturers that I know. And it just comes, they program it, and it goes, and that was it.
So Gary says when he was young selling computer mainframes, there was a show in Detroit called AutoFact. They were beginning to introduce CNC systems. They required a mainframe, and they were in the millions of dollars.
Oh, I remember when I was working in an office building. You're right. I can't remember, it was a computer associate. I don't know if it's computer associates, but one of those. They had the whole downstairs of a office building. The floor was about 30 inches off the ground, and all the wires and all the air conditioning, special air conditioning in the building to cool the, like you see in what was I got Austin Powers, where the things are spinning around like that. And then they moved out. I wonder how much that cost to move all that machinery. But, what do they say now? There's more on the iPhone now than there was on the space shuttle going to the moon.
Mm-hmm.
It's crazy.
Technology, that's where we're headed. Well, we can't wait to look forward to seeing some of the stuff you can't tell us about, Frank, in the Amana line.
Well, you're going to have to ask Chris Miller about that. I'm sure he's listening now. He's probably back from vacation.
No, he's off on Wednesdays, remember?
Yeah, but Tommy came
Watch this later and be like, I can't believe you did that to me.
So you wanted to know the most question I get from Amana? It comes from our own national sales manager. Frank, I'm not going to be in. I'm busy. Can you take care of this for me? I knew I'd get you two guys.
Oh, Lord.
Yeah, whatever.
He'll find out about it later. We'll get a phone call or an email.
He was watching before because Tommy walked in here and said he just got home from vacation. He's watching Frank now.
Oh, get your jab in.
Yeah, I don't razz him. He's from the Carolinas. I got to razz him a little bit.
That's right.
So Frank, just to be clear, you do take phone calls about refrigerators?
No, yeah, I do. I mean, it all depends on which. It's got to be an Amana though, no LG or GE or anything like that. I don't know too much about that.
I heard he likes emails better than phone.
There you go.
It all depends if you want to send emails. You know what? No, Kyle, I don't like emails because they never put the information in the email. Here's one. I have a question on. Actually, he must have been watching this show. the engraving tool body, right? Is there any way I can download a tool holder model for this in Infusion? I don't even, a tool holder, was a collet or a tool holder? I don't even get it.
Yeah, because really all you need to know is the geometry of the cutting.
It's a 1/4-inch shank, right? So what would you need a tool holder to
I
load
don't
that
know.
in?
I know a Fusion, you have to like, it will take the measurements of the tool holder, but that's specific to your machine, not the tool. So
Right,
maybe-
the tool holder's a
maybe-
1/4-inch, 3/8,
Yeah.
a 1/2 inch, 1/8, you know?
I don't know. So Kyle, tool holder, how is that term used in Fusion?
It's like when you have like an automatic tool changer, it'd be like the holder that holds the bit.
Yeah,
know,
but
like
you
the-
lock that in, Kyle, right? You have to tighten it in the tool holder and put the tool holder, and then the machine comes over and picks up that tool and you
Yeah,
change the tool.
exactly. But Fusion, it will take into account the size of that, so just to avoid collisions and stuff like that.
So how am I supposed to? Sorry.
Well,
Yeah,
you guys
Well,
don't
you
supply
Amana
tool
guy.
holders, Frank?
I'm sorry.
Do you supply tool holders for CNC
do have-
machines?
We do have some tool holders, yes.
Yeah,
And
but that's
I'll say if that's one thing that's my weakest, that's it. You know, I
Yeah.
mean, I know ER32, ER40, but when they say I need it for my machine, you know, they throw out a machine, and I'm like, you know, what does it look like? Does it look like this? Or look like this? No, it doesn't look like any of those. I don't know. You know, third base.
yeah. Well, to Kyle's point, the tool holder comes into play if you're trying to avoid interference, if you're cutting deep or something, so the collet doesn't run into the side. But
yeah.
Right.
that's more of an application on the user's end, I would usually.
Yeah, but you see, that's, you know, I get a lot of end users and guys that I'm new to CNC, just like you say, and, you know, they're dying for information. I try and give it as much as I can. I mean, you want me to have them call you? Just put your phone number here. Call 1-800. Ask Randy.
A lot of that too, there's more information required, and we get that a lot from
Right. Yeah.
our chat lines. And, okay, you said you're looking for a saw. Well, what kind of saw? I mean,
seesaw?
hand saw, table saw. You know, what kind of saw? You know, so yeah, it's tough working with a lot of the new folks, but you learn to ask some of the questions needed on your reply email.
Yeah.
And CNC, because it's so new and because of the technology, the computer, the software, we got to be honest, there's a significant learning curve to this.
Mm-hmm.
You know, and it makes it look simple, and people want, you know, they see the sizzle and they want the steak, but you know, we see you got to cook it, and you got to go through some of that work of figuring it out. So that's why, you know, starting people off with the basics, it's really easy to get overwhelmed, and people have to commit to it. I compare it to learning a musical instrument or learning a language. You know, you start out, it's really bumpy along the way. Like piano, you're pounding away on it. You get a little bit better, a little bit better, a little bit better. But you got to keep practicing too, because there's so many things you can forget along the way.
Mm-hmm.
So,
Now, would you say that there would be a book out there that someone could possibly purchase to help them along if they are a beginner?
I think there's a great book out there. Would you happen to have it?
Yeah, it's called CNC Router Essentials by Mr. Randy Johnson. It's at woodworkingshop.com, and it's 30% off this week.
All
Send me
right.
a-
Thanks, guys.
Send me a copy, will you? I need to read that book.
Yeah, I will, Frank. I'll even
Maybe-
sign it for you.
I was
So
gonna say, get
listen-
an autograph.
Oh,
copy.
would you? That'd be great. Hey, I just tell you, I have a friend of mine's an engineer. One time he called up to customer service and he says, I need a special kind of blade. And she said, what kind of blade, what kind of machine do you have? You have a saw. So what kind of saw is it? He goes, a seesaw.
Oh gosh.
I know. It's crazy, isn't it?
And you know, with that, if you're interested in learning more about your CNC, you can go to learnyourcnc.com and check out Kyle's weekly classes, or you can take the master course with all of the step-by-step lessons, and they're broken down in very easy to learn sessions, and even got a little quizzes or two here and there scattered in, lots of tips and tricks with keyboard shortcuts. And then, of course, you could always join his Facebook group and learn a little bit there and join the crowd. And go to his not only his website, but his YouTube as well, and check it out over there for his weekly tips.
Yeah, if you enjoyed that video that we had earlier today, you can look forward to more of that at learnyourcnc.com.
That's right. And act now, because just like everybody else, his prices are going up.
Well, not only that, he's structuring it completely different. So it's going to be awesome. If you want the full masterclass of everything from Cut 2D all the way to Aspire, now is the time to get it at the best price you're ever going to get it. Because then Kyle likes to get more LED lights and make his background look even brighter. He's going to raise his prices soon. So go check it out. Oh, there he is. He heard you.
Oh,
Good show so far, guys. Just getting in from vacation.
yeah, 3 hours ago, just in time to not participate in this.
You know, they have
That's-
3G on vacation.
yeah.
I was driving, kids. And as they say, operators are standing by to take your order. Call 1-800. There you go.
28000.
There you go. You guys forgot that stuff, for God's
Right.
sake. Come on. This is a
Getting
selling
there.
show, isn't it?
We don't try to do the sham wow thing too much. We just try to pepper it in a little bit.
Well,
Yeah, we give it where it needs it.
you had your sales voice there, Mike. That's pretty good. Hey,
You're welcome.
come and get it, baby. We got it now.
So yeah, we've got we've got the bits on sale. We've got the machines on sale. So check it out. Kyle's got his Learn Your CNC on sale. Well, not on sale, but it's a good price
Well,
right now. So
I was going to say, technically, it's on sale compared to what it's going to be.
So I don't know if you guys have had to travel any, but we got kids living in Arizona, grandkids, right? So basically, my wife calls up JetBlue to complain about something. It was like, operators are standing by. It's 1 hour and 30 minutes to get a wait, stuff like that. It was
yeah.
That was crazy.
So, Mr. Coleman Forsey says the best woodworking show ever. Klingspor's Woodworking Extravaganza will be live again next year. Clear your calendar now for October 2022. Our 22nd anniversary show will be the biggest ever. We get a bigger building.
the
Come
biggest
meet
whatever.
Come meet Chris Miller at booth Amana Tools booth.
By then he'll be down to working Monday only.
No, 2 hours a day.
If he comes, I would rather him just show people how to turn pens.
He's a good pen turner.
Oh yeah, that's how I got to meet him. I had no idea he was a national sales manager for anybody. He just came in looking to learn how to turn pens.
7 years, he never offered me a nice pen. After all the work I do for you, Chris.
Oh,
Come
my
on, huh?
gosh.
Hey, he's listening.
I know.
You know what? Next time he calls and says, "Hey, can you answer this question for me if you send me a pen?"
Yeah, it's a good.
Hey, let me write that down real quick. Oh wait,
I can't. He's the best, though, Chrissy.
Yep.
He had a good vacation, baby. He was in high cotton for free. Can't get
Well,
over
I'll tell
that.
you what, we sure appreciate you guys coming out and
Thank you.
willing to share your time with us. And Randy, you double took it on that one, coming back twice, so we appreciate it. And if there's any questions that come through for folks that watch the videos after the fact, drop your comments. If it's something we can't answer, we'll certainly reach out to one of these three gentlemen and get you the correct answer that you might be looking for. And
Well, I'd just like to say, Kyle, it's nice to meet you. Randy, it's nice to see your face again. And if I can do anything, please don't hesitate to call me. Okay, I'm always available between 9 and 4:59, and and I got lunch between 12 and 1.
on every day that ends in Y.
Every day that ends in Y. And don't call me between 1 and 2 because I'm the only one to answer the phones, and so it's a little hectic.
it's getting off. I mean, you're getting awful picky now. I mean,
Oh, well,
before it was call me anytime, and then it's anytime between this and this,
Well-
and then just don't call me between this and this, and
Yeah, well, I mean,
whatever you do, don't call me at this time either.
if you want to get a live person, that's fine. If not, leave a message. I call you back. I call everybody back. I made a promise that I called everybody back by the end of the day. I call back and the guy picks up. Say, "I call you back. I'll tell you tomorrow."
How you called back? But thank you, gentlemen, very much for joining us on our CNC discussion. This was a lot of fun.
Anytime, boys. Anytime.
It's always
Thank
good
you.
with you, Frank. Well, it was nice to meet you, Randy. It's the first time I've ever met you, so it's wonderful to meet you and then learn your story all together because there was a lot more to it than I knew. So I'm glad to learn more about you. Kyle, I again apologize for pronouncing your name incorrectly for all those years.
That's okay. Everybody does it.
So for Klingspor's Woodworking Shop, thank you for joining us for our session today. Tomorrow is going to be Turning Thursday. So we've got Robert Sorby, Morris Schlesinger, Scott Caskey, a lot of turning going on all day tomorrow. So join us for that. I am Mike Z with Klingspor's Woodworking Shop.
I'm Chris, and we will see you next time.
See
All
you
right, take care, guys.
boys.
See ya.
Take
Thank you
care.
very